Welcome to Tuesday night, back where it should be. This is my first Tuesday since I think March. We had Ultimate Frisbee games on Tuesday nights, and now we don't anymore. So back to where it should be. All is right with the world, and it just keeps spinning. Anyway, Dicey Dr. Blitz is in the chat. Welcome, Dr. Blitz. If you want to join, you're welcome to join. Send me a message on Discord. But this is just to enjoy watching and the SmackDown you delivered to Soli. If you didn't know, last Thursday I debated Soli on or Soli, I'm not sure. Whatever. It's solipsisms. It's short for solipsisms because he's so philosophical, bro. And top left just keeps getting delayed. People are busy. Anyway, so he had contacted me like 3 weeks ago, and we set it up. That was pretty good. It was going to be on Jaren's, but Jaren's got other stuff going now. His channel isn't making him money, and he's like, he's like, I just can't. So it was on Modern Day Debate. Anyway, that was Thursday. Monday, which was yesterday, the day that is yesterday, Soli volunteered again to receive a SmackDown, and as Dr. Blitz is well known for saying, it did not go well. So, Roger the Antarctic Explorer says, just give me my prize, please. No, the winner for top left is, of course, Mikey Smith, who sued the Canadian Space Agency and lost. Anyway, so we're gonna watch this. It's a bit over an hour. If you want to watch it on your own, you can. The link is in the description, and so you could just go watch it there. And so what I'm going to ask you to do is to help out Dr. Blitz. If you're on a desktop, open that up in a different tab, pull that to a different window, set the volume low or something like that. Give it a thumbs up, give him a subscribe. Make sure you've done all the stuff that you should do because he does a great job. I love having him on. I don't comment. I can't. I gotta focus. Like it's when I'm working, so I'll have it right here. I'll have it playing right there at low volume and just listening to him. It's always good. But I didn't work yesterday because it was Memorial Day. So I've seen just parts. So, Dr. Blitz is the Drunk Debunk's spirit animal. That's amazing. Okay. Well, anyway, here is a photograph of the Earth. And here's a series of photographs of the Earth. Look at that with satellites going around it. Anyway, and here is the video of Blitz and Soli. Here we go.
Would you agree that you just got cooked, bro? Please. Like,
no, this is hilarious. They will travel as if the Earth is larger because of the refraction. Oh, the Joker laugh is not a good look if you're trying to not be thought of as crashing out. Soli, how's it going?
What's up, man?
Not a whole lot. Soli, what shape do you think the Earth is?
Oh, it's not a sphere. It's definitely flat, bro.
All right. Why do you think so?
Measurements, microwaves, particularly. Microwaves are pretty compelling evidence. Can I ask you not a personal question, but not a non sequitur at the same time? Do you ever debate off of TikTok?
Like on modern day debates or something like that?
Yeah, would you ever consider something like that?
I have before. It'd have to be I'd have a really compelling reason to do it just because I'm already so busy, as is.
Okay, I was just going to put the offer out there, but we can move back onto the subject. So microwaves travel line of sight, right?
So hold on, Globy McGlobeface here says Soli got destroyed twice in 2 days, and now he wants to schedule a debate with me. I don't get it. I don't get it either. And FTFE is trying to schedule a debate with him, but he's having a hard time. I mean, really, what happened is Soli chummed the water. Really, he chummed the water, And FTFE's like, oh, I want me some of that. And then he went in with the Blitz, and now he wants to chum the water even more with Galobi. I mean, the guy just wants to get beat up. Oh, poor guy. I mean, I don't know why do you want to get beat up so badly, Sully? But okay, I mean, people are obliged, right? They're happy. They're happy to give you what it is that you want.
Well, they can, surely.
Yeah, they typically do. They're actually, according to NASA...
I mean, they also refract, right? Like all electromagnetic waves refract.
According to NASA, they're not affected by rain, sleet, snow, clouds, smoke. They're not really affected by that.
But you do understand that they're electromagnetic waves, so they refract?
Yeah, they're on the electromagnetic radiation spectrum, sure. Yeah.
Yeah, so they refract, they can reflect, like all electromagnetic waves.
So if we have world records of up...
Okay, so this is interesting because on Thursday, he had some citation, I didn't recognize where it was from, claiming that microwaves don't. But and he asked me about it, and I said, is that citation wrong? And I said, yes, that citation is 100% definitely wrong. Everything in the electromagnetic spectrum does indeed refract, reflect, and diffract. And depending on the frequency, it does it differently and interacts with matter differently. But they all do. In fact, there are microwave lensing antennas. Now, if you don't know what that is, a microwave lensing antenna, you'll have on one side, you'll have a transmitter, and it could be a dipole, it could be a monopole, it could be a microstrip patch antenna, something like that. And on the back end, it'll have a reflector, which is typically just a grounded, flattish area of conductor, right? And the distance between them is important, not hyper important, but anyway. And then a tube, and that tube tends to then also be shielded so that it's a waveguide. And then at the end of it, it actually will have a lens, and a lens that very specifically is shaped and is made of a material that's refractive conditions are such that it will actually focus the photons coming out of it so that you can get a higher gain out of it. And that works for any particular frequency of radio waves. You can make that for really anything, but higher frequency, microwave frequencies work better because you don't need it to be so large. Something that's 868 megahertz, to have a lens like that, you need to have, should be at least 1.5 wavelengths. And so it's pretty big. 14 inches, if I remember, is from the top of my head, would be how big that lens needs to be for 868. Not important in this instance. That's more of a Mark Steele is an idiot kind of thing. So anyway, you can do that. But anyway, so now the question is, Soli, why did you drop that? Was your citation, did you look into your citation that was wrong and find out it was wrong? I don't know, but he's not arguing that microwaves don't refract anymore, as he did when I spoke to him on Thursday. Jesus Craig says, I never get the time to catch you live, so I usually watch the VODs later at 2x speed. Now it sounds like you're slurring your speech because of that. I'm not slurring. The VODs. Anyway.
To like 4,000 kilometers, right? And some that are even farther than that, but I couldn't actually, when I tried to trace the call signs to and fro, I couldn't really find like that you had to log in to get that information, so I couldn't access that. But I've gotten distances from like the coast of Hawaii, some island in Hawaii, I don't have all of those memorized, to all the way to California, which is about 2,500 miles.
Sure.
What would be a logical explanation for that, do you think?
Well, I mean, like, look, depending on the frequency, and microwaves and radio waves are similar, but depending on the frequency, you can have bouncing off the ionosphere, you can have atmospheric ducting. So, like, this is My view on microwaves, and generally on using electromagnetic waves like light to try to figure out where we are. I mean, like, flat earthers like to say that, you can't look at the sky to figure out what the ground is. Well, I don't think that you can look at things that bend to figure out what shape the ground is either, right? So, well, my general view is we should appeal to things that don't bend, that don't have these extra variables that can confound our experiments, right?
Well, that's the dilemma that I'm having, is that I'm finding it difficult to believe that it would bend.
You don't think that electromagnetic waves? You don't think that electromagnetic waves can interact, can refract, can reflect?
Well, the dilemma that I have. The dilemma that I have.
That's cute, Soli. You're so good. You know this topic so well that you, better than any other person in the world that's actually studied this for more than 2 weeks with ChatGPT, you know better than them.
Right. Is that if you look at like link planner or path loss,
I have no idea what that is.
It's where they model these out mathematically. Okay. Mm-hmm. When they after the
are these like websites or are these like manuals? Like what are they?
It's websites, right?
Okay.
You can actually there's actually like amateur websites where you can plot out your own microwave transmission before the fact, and what you do is.
Now remember, on this is interesting. On Thursday, he claimed that, quote, before they launch the transmission, they plan it out in Link Planner before they launch the transmission. So he thinks that people are on a boat and they're gonna in the military and they're gonna send off a communication to another boat somewhere, and they're like, oh well, before we launch our transmission, let's go get a measurement of the physical properties of the air between here and the distant place, so that we know whether or not there is currently tropospheric ducting happening. No, that's not how it happens. Oh my gosh.
You fluctuate the value of K, your coefficient of K, and that effectively...
You mean your coefficient of refraction?
Agreed, that is what it should be, yes.
Sure.
But what it actually does in the mathematical model is it changes the radius of the Earth. They don't bend the light in the modeling.
Do you understand what K is doing in the equations?
It's alleged to be. It's funny because I have a whole PowerPoint put together because I get conflicting answers when I looked into. Like, did you understand? Would you admit, or are you?
He didn't finish his sentence.
Aware that the value of K can be infinite?
It could be quite large. I've seen it measured up to like 10 or 15, but I don't know if it's ever been measured to be infinite.
So this is the different value of K that I ran into. So typically in the literature, and this is probably why Blitz was a little confused by it. In the literature, lowercase k is used as but Soli is not using it in this manner. It is the coefficient of refraction, which is a value of 0 means that the light is going in a straight line, and a value of 1 means that light is curving at the same radius as the radius of the globe. That's what the coefficient of refraction is. Now, he's using this capital K, which isn't used as much in the literature. I haven't seen it nearly as much, where it is the ratio between the effective Earth radius and the real Earth radius. And so that one, when it goes to infinity, does mean that the light path is not curving at all. So a value of infinity in the K that he's using, uppercase K, is the same as 1 in the primary usage in the literature. Now, there is also in the literature, especially in the German stuff, because there's a lot of refraction stuff done in German, because who did the early real quantification of refraction was Gauss. Gauss was German, so there's a lot of writing on the bending of light in the air using refraction. There's a lot of literature in German. So if you look at some of the documentation in German, the literature in German, they use yet another version of K. This is still lowercase k, but the values get significantly higher. And I've not been able to, and I worked with somebody who did speak German, he He didn't know either. It was just a few things. Anyway, if you go to my website, mctoon.net/refraction, you can see, in fact, there's a graph, and that shows on the graph where the coefficient of refraction is spiking shortly after sunset on a hot day, and it's going up to a value of like 20. That's not the same K as the other one that I was talking about, where a 1.0 means that the light is bending at the same radius as the globe. It's confusing. That's 3 different values, definitions for K. And so using a different value of K and thinking that you've got some sort of a gotcha isn't a gotcha. And misconstruing it and using the wrong version of it also is not a gotcha. Anyway, there's the background. You can read all about the refraction on my website, mctoon.net/refraction. There's a whole bunch of literature on there.
Yeah, there's a formula that you use to derive it. You take your atmospheric refractive index, your N, and you divide it by, your denominator would be the true radius value of the Earth, 6,371 kilometers. And if your refractive index is effectively...
Wait, how did you use N? He didn't explain how to use N.
0, which sometimes it can be, you can't divide by 0, right?
So no, your refractive index can never be 0. Also, 0 divided by the radius wouldn't give you infinity. It would give you 0.
Maybe I do misunderstand, because it is something that I've been looking into for a couple weeks. But effectively, there is a value. If you even just Google K equals infinity, you get all kinds of information on it. It's very interesting stuff. And that effectively means that they make the radius value of the Earth infinite.
Making the radius value of the Earth infinite, according to the formula that you just gave me, would make the K value 0.
It would make it negative...
The coefficient of refraction divided by the radius of the Earth. If the radius of the Earth is infinite, then your coefficient of refraction, or then your that ratio is 0.
I would have to pull up the slides. I'd have to boot up my laptop and show you. So maybe we could do this on a different day. I can always come back, because I don't want to take up all of your time. You're
I mean, so this is the thing that's measurable, right?
Why did he come in here if he wasn't ready? And what, Sully? So what are you doing with your time? Like, it was Memorial Day yesterday. What were you doing that you didn't have your laptop handy? Are you still in the hotel you were on Thursday? So many questions and no answers.
Like, we can measure K.
We measure the atmospheric refractive index. Yes.
Yeah.
Okay, and he still doesn't understand this. The refractive index. That is a refractive index for one medium. But the bending of light isn't because the index of refraction is a high value or a low value. Because in a medium where the index of refraction does not change, light does not bend in that medium. It's when it goes between mediums that have different indexes of refraction. The classic example is in and out of glass, like these, right? Or the cover of the Pink Floyd album. But it doesn't have to go between distinct mediums. It can be within the same medium, but a varying index of refraction. And so what is happening in the air is you have low in the air, cold air, more dense. And as you go up, especially above water, and as you go up, it gets warmer. This is the base condition, because water tends to be cooler than the air. It's not always the case, but it's often the case, especially on a warm day, because the air can warm up quickly, but the water isn't going to change very fast because the water has a high specific heat. In fact, it has the highest specific heat. So you'll see that temperature changing, and the temperature in this instance is what's causing the variation in the index of refraction. So cold down low, warm up high, a higher index of refraction and a lower index of refraction. So that varying index of refraction is what causes the curvature. And that's what you feed into lowercase k, the coefficient of refraction, where that takes the variation in the index of refraction and quantifies it in a relationship with the radius of the Earth. Because when you're doing surveying work and things like that over the surface of the Earth, what you really need to know is how it relates with the radius of the Earth. So when they're doing their modeling, they're not making the radius of the Earth infinite. What they're doing is they're saying, well, in order for the light to track the same path as the surface of the Earth, it needs to curve with that same radius. Lowercase k, coefficient of refraction equals 1. Or in the uppercase k that Soli is apparently only found this less common literature, as far as I know. Maybe it's more common. I didn't find it much in what I read. Where it's more specifically about the effective radius of the globe, right? So you've got the ratio between the effective radius and the actual radius. And it's like, they model it flat. Well, they only model it flat for when the radius of the arc of light equals the radius of the Earth, which is not very common. It's a bit of an extreme refraction case for that to happen. Typically, it goes higher than that. And if you look at FE Core and their what they thought was their awesomest laser test across Lake Balaton, you can look at the temperature measurements that they made there, and you can see that the K index, the coefficient of refraction, is going to be significantly more than 1. Okay, that's a lot of background. You got to know it, but Soli's doesn't know it at all.
And so it can be quite large. Like
There's a formula for that. It's like 0.776
I'm not talking about a formula. I'm talking about just making direct measurements. I'm looking at a table right here that has direct measurements of the index or of the coefficient of refraction, and it peaks at like 15 in this graph.
Well, are you looking at big K or little k?
Ooh, he got that right.
Coefficient of refraction. I don't know what convention you're using for the naming.
That's
the naming.
lowercase.
For like standard refraction that we use in like plane survey.
Oh my goodness. It's not standard refraction or non-standard refraction. It's just a different way of doing the modeling.
And there's another that we use, which is a small k, not capitalized.
1 second.
And we use it for microwave waves. Yeah.
What? We don't use it just for microwaves. Oh my gosh. Soli. Oh, 2 weeks and ChatGPT did not prepare you.
And that value can go up to an
so this is for optical refraction, to be clear. So we're talking visible wavelengths of light. We're not talking microwaves. But
no, we're talking non-visible.
But no. I mean the one that I'm telling you about. But to be clear, the phenomenon is the same. Right? It's electromagnetic waves. Electromagnetic waves bend when the medium is changing its index of refraction.
This is the dilemma that I have, right? Is that it is claimed to be a refractive index bending the light, the transmission, right? But when they model it out in path loss, they don't bend the transmission around. Like you would agree that it's the radius value of the globe would always consistently be 6,371 kilometers.
Sure, whatever
minus
the number
like
is.
sort for the semantics. I understand it's not a perfect sphere, right?
Whatever the number is, about 4,000-ish miles, right?
Yeah. But they use the metric system for this.
I understand.
Yes, absolutely.
Blitz has dealt with flurfs for long enough that he knows that flurfs can't do metric, and so he's translated everything to imperial because he knows the language that you have to talk to them in.
So that would be your constant, right? So when they fluctuate the value of K, that should always be you're fluctuating the refractive index, not really fluctuating it, but
coefficient of refraction. The refractive index is varying. That's why the light bends.
measuring it and then incorporating that and bending the frequency around a constant of 6371. But when they model it out mathematically, and I can link you to sources that show this, they don't
I
actually
believe you.
do that.
It's because,
Please don't interrupt me.
It's because, well, I'm answering because I know what you're saying. The point is that
But they
there's two
flatten
ways
the
that you
Earth.
can there's two ways that you can
They
model this,
flatten
right?
the Earth underneath of it, sir.
There's
They flatten the Earth
there's two
underneath
ways
of
that
it.
you can model this. You could either solve a very complicated differential equation, which would involve a changing
They already do
angle.
that.
Sorry,
Take the derivative of
which would
n
involve
and
the
divide it by
change.
the derivative of z.
That's not the complicated angle, the complicated differential equation that I'm talking about. You could either take a complicated differential equation around a curved Earth and use the changing index of refraction of the air around the curved Earth, or you can just and you can check that these two things are going to be formally equivalent, mathematically equivalent, or you can set the index of refraction to be constant and just treat the Earth as larger, and those are going to give you the same answer. It's just one is much more numerically challenging.
Good job explaining that. It went over his head, but that's a good job explaining it.
Do you see how that doesn't exactly build confidence in someone who's trying to find evidence?
You just actually have to look into the mathematics here, right?
I have. I've looked into the mathematics quite thoroughly, and yes, they do use calculus.
Can you detail what differential equation you would have to use to solve for the path of a light? Sorry, the path of a ray, like an electromagnetic beam, on a curved surface with a constantly changing angle of refraction?
Oh man, Blitz. This is gonna be great. This is gonna be great.
Yeah, you would take
a complicated calculation.
You would take the derivative of pressure and temperature, respectively, output over input, and
what? You need to know the varying index of refraction. Oh.
And compare that to the elevation, right? You take a derivative of z.
Right, and then you need to map that onto spherical
you only
coordinates.
you only have like one extra variable.
Then you have to map that onto a spherical coordinate system. And that's tricky, because solving those differential equations, especially if they're second-order nonlinear differential equations, they can be really complicated.
So they take it from a hyperbolic coordinate system and they change
hyperbolic
it into a Euclidean system? Well, it's still non-Euclidean, or it's still Cartesian, right?
No, not necessarily. Not if they're using spherical coordinates, or in this case, polar coordinates.
Well, we map it out using Euclidean and 3D Cartesian. Yeah.
So it looks, and actually, this is actually a good point, because when you have what's the correct word here? There are certain differential operators that show up in.
Okay, so did he tried to pull out this hyperbolic coordinate system? Was he just trying to make like he understood? That's got to be it, because a hyperbolic coordinate system is not what you'd use in this instance at all. And Blitz is saying you could do it on a spherical coordinate system, but then he simplifies it and says, oh, you could do it on a polar coordinate system. That's totally correct. That's how you'd want to do it. You know, you'd track the path of light, assuming that it's not varying left to right, which is generally a safe thing, because over the surface of the Earth, you don't get horizontal temperature gradients or horizontal index of refraction gradients. You get vertical gradients like that. So the light's going to go left and right. It's going to go very much not left and right. So you could take just that slice there and intersect the plane. And so then that just gives you a polar coordinate system. And yeah, doing the calculus for that whole thing on a polar coordinate system, that will not be you're not going to have a good fun time unless you really enjoy doing that type of stuff. That's pretty complicated. On the other hand, if instead you say, well, we know how the index of refraction variation can change the radius of the path of light. And when you change the radius of the path of light, it will interact with the surface differently. And if it's the same radius as the surface, well, we know something about that. We know that nothing will get in the way. You're going to have optical effects, but the light will get there. And if it's a long enough path, you're going to have incoherent, you won't be able to make out detail, but the light will still get there.
And they have different representations in different coordinate systems. In Cartesian coordinate systems, Laplacian operators, certain differential operators are particularly simple, because the coordinate system doesn't change as you move from place to place. It doesn't turn, it doesn't bend. However, if you take that same differential operator and you try to use that differential operator on a curved surface, that operate, or rather in a curved coordinate system, like in polar coordinates, spherical coordinates, whatever it might be, that differential operator can become a lot more complicated, which is why one of the things that you learn when you're taking a class in differential or in differential equations is you learn certain coordinate transformations that can make solving the differential equation easier. So
I completely agree.
The way that we take measurements, the way that we evaluate things
He completely agrees. Now, let me remind you, without knowing his background, I know for certain that Soli has never done anything in a polar coordinate system ever. It probably wasn't until 2 weeks ago that he had even heard about polar coordinate systems and that they exist. I don't know. Maybe he heard before that. But he certainly has not ever done anything in polar. And then beyond that, never has he taken any class in calculus. He's never done a differential equation. He's never done a derivative. He's never done an integral. None of this has ever happened by Soli. Not once. He did not take calculus. And I can say with certainty that in high school, he did not even take the optional physics class as a senior. I know that. I know that's the case. There's all of maybe 5 to 10 flat earthers in the world, on the globe, that ever took a physics class. So it's safe to say that, just so you know.
The way that we take data often is using Cartesian coordinates. You're right, because we live in this three-dimensional world and it's just a convenient set of coordinate systems. However, if you want to then solve for a trajectory on a curved surface, which is allegedly what we live on, you have to take that data, coordinate transform it, and then solve a complicated differential equation across the surface of a circle. In this case, my point is that there's two ways you can do this. You can either solve the complicated differential equation, or you can get the exact same answer out just by treating the differential equation as an algebraic equation, which is what happens if you treat the coefficient of refraction as constant, the coefficient of the refractive index as constant, and then just treat the Earth as larger. They will give you the same answer. One is significantly more numerically expensive than the other.
Numerically expensive. It's literally one extra.
That's solving the differential equation.
I let you finish, sir. I let you finish. So it's not actually that much more complicated. It's an additional variable, right?
Oh my goodness. It's not an additional variable. You're going into calculus versus staying within algebra.
It's actually not that much more complicated. And if this is just concrete.
Look at Blitz's face. That's it. That's it right there.
As I believe it to be, it doesn't, like I said, it doesn't exactly inspire confidence when we quite literally extend the radius value of the Earth theoretically in concept to be infinite in value. And if you would agree with me here, if you have a sphere with an infinite radius value, it can't exactly be a sphere anymore now, can it? Because it's not even any shape, really. But the surface of that shape would objectively be flat. So they do flatten out the Earth. Even when they incorporate 4/3.
What?
Yeah, even when they incorporate.
And it's very rare. I don't know why he's taken this corner case where in very specific and rare instances, the coefficient of refraction is exactly the case where the path of the light ray is exactly the radius of the Earth. It can be slightly less, it can be slightly more, but no. Never mind all of those normal cases where it's the massive quantity of the time. Let's focus on just the very, very narrowest instance where the coefficient of refraction causes the light path to exactly be the radius of the Earth. No, that's not how it's done. In general, it's done that way only when the coefficient of refraction is that particular value, and it's just generally not.
Incorporate 4/3, like standard refraction, what they claim to be standard refraction, 1.33, they still flatten the Earth underneath the transmission.
When you say flatten, it doesn't make it flat, it makes it bigger radius. That's what you mean. Yeah. So,
it makes it flat.
To be clear, are you familiar with solving differential equations? Like, is this something that you are...
To some extent, yeah.
So, would you...
To some extent.
Would you be able to write down what the differential equation is for a electromagnetic wave on a curved surface.
No, not with electromagnetism. No, not necessarily.
Which is what a microwave is. So you have an electromagnetic wave on a curved surface with a changing index of refraction.
The problem that I have is that I'm no expert, right? But these people are
I believe you.
alleged to be experts. So why are we simplifying just for the sake of simplicity's sake?
Because
right?
you get the same answer. Why would you bother solving a harder problem when you can get the same answer?
You get a radius value that is infinite, sir. That is not the same answer.
Look, the answer that you're trying to solve for when you're doing these kinds of calculations is like, where is the microwave going to end up when I go this far away? That's the answer. The answer is not the radius of curvature. That's used as an input so that you can get the answer correct for when you want to figure out where the microwave will end up 600 kilometers away. That's the point. Right? Okay. You're not actually, like, we're not saying the radius is actually changing.
2,500 miles.
I know, I was just giving you an example. We're not saying the radius isn't actually changing, right? What's happening is that you are modifying your model so that you can capture a complicated feature with a simpler feature. Does that make sense?
Okay, so can I give you a thought experiment, right? Like, if you have a location, like from Hawaii to California, where we had to make the radius value of because in cases of tropospheric ducting, they always use k equals infinity. This is objective, right? They always
I've never heard that claim, but I'm also not a microwave technician.
That is objectively true. If you do a little bit of research into it, you will find that. Yes, that is objectively true. And then if you have one location from California to Hawaii where tropospheric ducting is used, and k equals infinity there, and then you have another location like outside of Perth to Australia, right? Like, then you have another location where the radius value is infinite. Your model's not exactly a sphere anymore. Does that make sense?
No, I mean, it is still a sphere as long as you have a non-infinite radius. And by the way, I'm not actually seeing that they use an infinite coefficient of refraction. I'm not seeing that anywhere. I tell you what, bro. If I had my laptop, it's at like 30%. I don't feel like booting it up.
Yeah, you'd be cooked, Blitz. You'd be so cooked.
It's gonna die.
That's fine. That's fine. We don't.
I was gonna grab my engineering math book from Kurzik, but I don't know where it is right now. This is my calc book from college. What is this? That's a bookmark. I haven't used this. I don't think I've used this since college. I don't know why I kept it. Right. I sometimes it's you'd keep it because they were moving to a different book the next semester. Sometimes I'd keep a book. If they're using it, then they won't buy it back, right? Sometimes I'd keep a book because I liked it and I thought I was going to use it in the future. I generally never did. Or sometimes I'd keep a book because it was too beat up and they wouldn't pay much for it. And this one, the binding is a little messed up. So my guess is they thought this was too beat up. They don't want it. And that's probably why I still have it. I don't know. But that kind of book, Soli never touched. Not even once.
We don't have to go over that now.
So do you have time? I will show you if you have time.
I mean,
do you have time?
I don't have like 2 hours, but if I have some time, I have like 10 minutes, but I don't know how long it'll take. The point is we don't like, I can just grant you that this is contentious. I can just grant you that this is contentious, right? That there is apparently some sort of contention between flat earthers and globe earthers here. So what we could do is, instead of using things where like clearly
right, before Blitz is him here. One of the favorite fallacies that Nathan Oakley likes to claim is the reification fallacy. And that's where you take the model and you assume that the model is reality. Right? And that's called a reification fallacy. And that's exactly 100% what Soli's doing here. He is taking the model and saying, well, because at some point in time, almost never, but sometimes they use a coefficient of refraction such that the radius of the Earth is infinite, therefore it's flat. Nope. That's not reality. You're just doing a reification, right? In that model, the radius of the Earth is still there. It's still in the model. it's just as Blitz said, they're doing something so that you can figure out the answer to the problem that you're trying to answer. They're not doing it because it has some sort of perception to uneducated idiots that are looking in from the outside without knowledge about how things are done. Flat earthers, right? They're not trying to choose how they solve problems so that it looks different to a flat earther that doesn't understand calculus. Nobody's concerned about that at all.
Electromagnetic waves are things that bend and like they do refract. This is something that's well understood. And the question is, how much do they refract and what kind of effect does that have? Instead of using electromagnetic waves, why don't we just use something that doesn't refract to try to figure out the shape of the Earth? That seems like a way of eliminating this extra variable, which is causing contention.
Well, see, according to NASA, these things don't even tend to refract. That was my original argument.
Oh, we went back to that. Let's see it.
It's obviously the case that all electromagnetic waves refract. This is like well understood physics. It's been well understood for 150 years.
There's
I don't
a
know.
possibility,
I don't
but when
know
you're highly
which,
focused at like
I don't know
maybe,
which NASA you're talking
on a wavelength of like 10 centimeters.
Crazy claim.
I can show you. With a wavelength of like 10 centimeters on such a highly focused, potent beam of electromagnetic radiation traveling in a straight path.
A potent beam of radiation.
It's not going to tend to refract. Here, I have the source right here. Microwaves penetrate haze, light rain, snow, clouds, and smoke. This is from science.nasa.gov/EMS.
Doesn't say anything about not refracting.
Okay. Unlike lower frequency radio waves, they cannot pass around hills, meaning they cannot diffract. They cannot pass around hills or mountains and are not refracted or reflected.
It does in fact diffract, but it doesn't diffract at the same magnitude as other frequencies.
Refraction. Go ahead, continue.
See, you're not letting me finish now. They are not refracted or reflected by atmospheric layers.
Okay, so they don't have to be refracted by atmospheric layers, but they can still refract, right? Like if I just Google, do microwaves refract? The answer will be obviously yes. Yes, microwaves do refract. Do you want to see the K equals infinity stuff?
I mean,
do you agree that this is contentious?
Do you want to see the K equals infinity stuff?
I mean, sure if you want, but I mean, the point is this is going to be contentious, right?
I mean, it feels like you don't want to talk about it. That's what it feels like.
Well, I mean, look,
he's pointing his camera at his laptop screen. And that's the problem with TikTok. People are on their phones, right? And so how do you have a debate where you're sharing information when you're on a phone? It really sucks.
Clearly like a gap in the understanding that's perhaps going both ways. Like I don't know a lot about microwaves. I'm not a microwave technician. I do know a lot about like electromagnetism. So like there's clearly like a gap that there's causing some contention here. So instead of talking about something that is contentious,
I'm trying to dissolve that. And just source my claims.
Okay,
so
sure.
Big box me.
I can't big box you. You're on 4 platforms and it won't show up on all platforms.
Okay, well
you can give me the source though.
You're not going to be able to read it.
What 4 platforms? TikTok and YouTube. What else Blitz are you doing? I don't know if he's still in the chat here.
Can you give me the source?
An accepted way to model this phenomena is to.
Like where can I find it?
It's a long one. westernstatesforum.org/documents/2006/2006.
Wait, hold on. westernstatesforums.org.
It's a PDF.
That's not NASA, is it?
Fine.
Doesn't sound like NASA yet.
2006
/documents/2006.
So Western States Forums again, /documents /2006 yeah, sure.
/2006/2006. There's 2 2006s.
Yep.
And then a percent symbol 20W.
Okay. So he's on YouTube and TikTok as well as MySpace and GeoCities. Yeah, thank you for that. DP debunks.
USRTTIF. Forgive them, band of motorcycle people.
WSRTTIF.
WSRTTIF percent 20 TURNBU.
Sorry, your audio's cutting out. TURN what?
Couldn't he just name the document and then you could Google it?
You there?
TURNBU.
GeoCities is dead, but you can in fact download all of GeoCities in a torrent link. It's not very big. That's all of those thousands of GeoCity pages all together. Now, years later, they're tiny. It's 2 torrents.
LL.pdf.
TURNELL.pdf.
BULL.pdf.
Sorry, your audio is just cutting in and out.
Big boxing me would make this so much simpler. I know you're more worried about what the audience can see, but I'm more worried about what you can see.
Literally, you're on 4 platforms that'll like break all of the live streams.
Okay.
So
well, can I just read it to you?
So it's 20,
an accepted
20,
way to model this phenomenon is to use a coefficient of k that modifies the mean radius of the Earth.
It's percent.
Why does it do that?
It's percent 20. TURBULL.pdf.
How about I just
email it?
I don't know why I can't just.
I feel like there's got to be
email it.
Listen, just hear me out.
WesternStateForums.org
I'm going to, but I feel like
/documents /2006/2006 percent 20 WSRTTIF percent 20 TURBULL.pdf. Is that correct?
TURNBULL.
Okay.
You only made one typo. That's really good, actually. Congratulations.
Saying that the site can't be reached.
That's actually really cool.
WesternStatesForums.org.
It's a PDF, bro.
I know.
It's
I
a
understand
PDF.
That. I understand
You're not going to reach
PDF.
it.
Is it accessible on the internet? If so, I can reach it.
Well, I will send it to you. How about that?
Okay. Yeah, sure. That's fine.
Oh my god.
Okay. And I'd like to read something that I found on this, and I can give you a different.
Oh, for reference, Soli was going to send me the so in the debate on Thursday, Soli claimed that there is an electromagnetic derivation of 9.8 meters per second squared. The lowercase g downward acceleration that was derived through electromagnetism, and he was going to send it to me. And I've asked him several times. He's like, "Oh, I got to get it." And then finally, he sent me 2 Google Docs links. Neither of them had it. They did have the one by Morton Spears where he tries to derive big G, the gravitational constant, using electromagnetism, which doesn't help because even if you can derive big G using electromagnetism, all that you get in the end is mass attracting mass. That's all it gives you. It still gives you mass attracting mass. But you know what? Here's what I'm going to do. I'm going to give everybody the links right here. 1 and 2. And you can have a look. There's not a lot of documents on there. There you go. You can have a look, and you can look through there to find which one of those uses electromagnetism to derive downward acceleration, lowercase g equals 9.8 meters per second squared. Anybody finds it, let me know. Otherwise, solely sending something to somebody after the fact, not something that's going to happen as far as I can tell.
Different source if you'd like to verify a secondary source.
The reason why I want to take a look at this is because like I don't know this source. Like, what is Western States Forums? Is it like a reputable source? Is this just like a slideshow put together by some rando? Like, that's the question. And so I'd like to take a look at the source.
It's a forum. It sounds like.
What about urgentcom.com?
I have no idea what that is.
Urgentcommunications.com.
I have no idea what that is.
He's just
what about
shotgunning
solutions.com?
Do we have any scientific studies or EDU sources or anything like that?
This is the efficacy of how microwave transmissions work. This is the efficacy of what you will find if you just Google k equals infinity.
Okay,
you'll find so many different things on this.
Okay, just Google k equals infinity.
Microwaves.
Okay. So I see microwaves 101.
That may or may not be it.
So
the
back
name
in
of the
2006,
PDF,
we contacted.
Here.
So apparently the stability factor is capital K.
Planning a microwave link. It's not just line of sight. Try that.
Okay. Planning a microwave link. It's not just line of sight. Sure.
Now, without knowing what's going to happen here, I know it's going to happen here because I've seen it before. Every single time a flurf has a citation, What do we know? The citation contradicts the Flurf's position. This is the first law of Flurf. And that's why he's so hesitant for Blitz to pull this up immediately. He wants to have it, he wants to be big box. That means on TikTok, you get the main portion of the screen. So he can show it, and he gets to control what is viewed. If the source is released and Blitz can pull it up, then Blitz can read the whole thing himself and understand it himself and read and find out where it's actually doing stuff, what it's doing, how it's doing this. And that's not going to go well for the Flurf. It never does.
There's a semicolon in there, but I doubt you'll.
Yeah, that's fine. Okay, so this is from Evans Engineering Solutions. So this is like a guy. I don't even know what P.E is, but that's fine. He's giving okay, so this is some sort of engineering thing. So he says, hold on, I'm just gonna pull it up for both of us, okay? So we can look at it together. Can we see it? So This is what we're looking at.
There we go. Look at that.
You're gonna want to go to page 11.
But this is the document, right?
Wait, why jump to page 11 and ignore everything else? We know why.
Yes, you're gonna want to go to page 11.
So I'm just going to scroll through if that's okay. So we have some theory, making sure you have a clear zone, accounting for propagating conditions, setting your fade margin, adding up against blah, 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 blah. Okay, so type of radio wavelengths. I'm sorry. What does that say?
It's a satellite. Looks like.
What's that right there?
Oh my gosh.
Yeah, that's a cartoon. Why don't you scroll down to page 11?
So why does your own document say that these waves are...
It's a cartoon. What? Oh my gosh. It's your citation. You absolute idiot. Oh, Blitz. Blitz. Oh my gosh. Oh.
can be refracted.
Oh my gosh. Oh, crap. Oh no.
You're cutting out again.
Oh no. My cutting.
You're cutting out again.
Out. No. Gotta go.
I'm gonna turn off your video. Hopefully the connection will be a little bit better. One more time.
Oh my gosh. It's like
This isn't just me, right? Chat, you guys can confirm.
Oh, this is so bad.
Probably isn't the best.
And suddenly,
It's not just me. Chat can.
and suddenly, his audio is dropping out. He just pissed his pants.
Confirm that your audio is like cutting in and out really, really bad. I can't understand anything that you're saying.
Oh. Man, this is what's critical. This is his citation claiming, where he says, this citation claims microwaves don't, his claim, refract. But page 2, is this page 2? Page 3. Page 3 of the PDF showing a diagram saying the words refracted wave. So certainly your citation is not going to support your claim that that radio waves or microwaves don't refract. Wow. Wow. Wow.
I don't know what you're saying.
Wow. Soli, this is bad.
He hit his lag switch. That's so funny, though.
Oh. Yes, and the satellite you don't believe in your own citation.
Plug your Ethernet cable back in.
My goodness.
That was real convenient timing. I'm actually curious what it says through the rest of it. Consider a signal from a transmit point to receive point. Okay, so there's some free space path loss. Okay. For Fresnel clearance of a microwave link, we consider the calculated first Fresnel zone. Fresnel zone is basically the region, if I remember correctly, it's the region in which... Oh, he left. It's a bummer.
He comes...
And Fresnel zone should be plotted on a terrain profile graph with Earth curvature. Huh. Why? Why would we do that? Oh, he's back.
Oh my gosh.
What does it say on page 11?
We're going to scroll through the whole thing and read it. So we have Earth curvature here, which is interesting. What is this K factor in path studies about? The K factor takes into account the refractivity in the atmosphere, which bends the beam either up or down. It is the effective Earth radius divided by the true Earth radius. In effect, the bending of the beam up or down makes it appear as though the radius of the Earth is less than or greater than the true Earth. A K factor greater than 1 means the beam is bent towards the Earth. Less than 1 means the beam is bent upwards. K factor considerations. For K greater than 1, the radio horizon is longer than the optical horizon, which allows shorter towers. K factor of 4/3 is used in most cases for planning a link. In wet coastal areas, however, K can be as low as 0.5. Lower K requires higher antennas. Interesting. I didn't know a lot of this stuff, so I appreciate you bringing this up. Going back to our STL path with K equals 4/3, okay, we have a new path with the curvature of the Earth included. Path is redrawn for K equals 1, true Earth radius. So we have more curvature and less curvature, I suppose. And so I guess the point is that you can get, you have to, you aim higher, so that's interesting. Now plotted for K equals infinity.
They would never use
flat Earth. Okay, yeah. So here we have a flat Earth.
What does that say after that?
It says flat Earth. K equals infinity flat Earth. It's also possible to plot microwave link in Google Earth.
Can I say something? Or are you going to monologue through this and act like you don't understand
wait, you wanted me to read it. So we have flat Earth, we have true Earth radius, and we have K equals 4/3.
I'd like to, this is you becoming extremely uncomfortable in front of an audience of 700 people.
Oh my gosh, no.
4/3 is the only one that they ever
the projection.
This is crazy.
Outside of, yeah, great, a cartoon. When we model that out in reality,
do you think that refracted waves don't happen? Do refracted waves?
We have to change the value of K to model that out in reality. We have to change the value of K to model that out in reality.
So why did you say that most of the time they use K equals infinity?
What's 4/3? What's 4/3, Blitz? We talked about that earlier.
1.33 repeating. It's a number.
Yeah, so you would divide 4 or 3 by 4, right?
No, you divide 4 by 3.
Or 4 by 3, right? 4 by 3. I spoke it right the first time.
Good job, Soli.
Your assumed Earth radius.
He's figured out division. What was that? I don't know. 3rd, 4th grade?
Divided by the true Earth radius. Yeah.
Right.
As a result of
refraction.
refraction.
So they changed the value, which gives you 1.33 of the actual radius value of the Earth. So they do not keep the Earth radius constant. They never use K equals 1.
It tells us what K is. K is the effect.
They never use K equals 1.
K uses the effective Earth radius.
You can't use K equals 1 because that would assume there is. Yeah,
it's not.
I know. I explained that to you before you asked me to source it.
It's not the physical radius.
You act like you didn't learn all of this from me before you brought up the document. Now you're learning.
Oh,
I mean, this guy
precious.
Explained it than you did, I guess.
So precious.
What does the K factor say? It takes into account the refraction.
So he thinks that because Blitz hasn't read this particular document, that he's got something. No, you don't. You don't have something on Blitz because he hasn't read this document. If it's a competition about who's more well-read, it's going to go to Blitz every time, Soli. Every single time. You spent 2 weeks with ChatGPT. Blitz got a PhD. Yeah, he's more well-read.
Where I got all the information
which bends
from.
The beam
Not all of it,
down.
actually.
So, wait a minute. Actually, I'm kind of curious. Why would they ever use K lower than 1?
Good question.
If
There's
the Earth
a
is
thing
flat?
called okay, there's a thing called sub. I haven't actually. They would use 2/3.
Sub.
Well,
they would use. I mean, if they're going to measure it, they'd actually just use the actual value, right? You might use a constant like 4/3 or 2/3 as an estimate if you don't know the actual conditions, or if you have some idea of the conditions. For example, if you're going to do peak to peak over land, 4/3 is probably too high, especially if you do it like on an overcast day or in the morning. You might use 7/6, and that's what surveyors like to use a little more often. They tend to do shorter runs, and they do prefer not to have extreme conditions. The American Meteorological Society uses 4/3 when they don't know the actual value, and typically you don't know the actual value. You don't have a string of temperature sensors between you and the other side to know what the actual path is going to be. You can't. It's just impractical. So what you need to do is you need to do things. You need to solve the real problems, right? You got a job to go do, right? We're going to need to get a vertical temperature or vertical site surveying, right? We're going to get a vertical angle. That's what I mean, right? Well, what's the conditions? What's the temperature gradient? What's the coefficient of refraction? What's the index of refraction gradient? We don't know those things, but we do know that we were not over water and that we were going from top to top and we weren't skimming the ground. Okay, well, in those cases, this is what's a useful number that happens often because it's been previously measured. That's what they're doing with these numbers. So, all right, I'll take a break from this for a second. I got a few people sending some things here. For example, we got the amazing Brenda creates this. To be honest, there are parts I didn't understand, and that's fine. The cool thing about this is we're all being educated and entertained. It's edutainment. So we can be educated and entertained at the same time. So Brenda, I'm with you. Now, I don't always know everything on these topics. And I enjoy learning stuff. So this is pretty fun to become more familiar with things like this. Anyway, Itoria says, gee, Willikers Batman, it's Toons Day. It is in fact Toons Day tonight. Unfornicated for $2 says check ITU-R P.834 for refraction of UHF and SHF. So let's see here. I will Google it. And the name of the document is Effects of Tropospheric Refraction on Radio Wave Propagation. And I will grab this right here and I'll drop it in the chat for anybody. There you go. If anybody's interested, there it is. We got unfornicated again, comes in with, says RF uses K equals infinite because the curvature is no longer impacting the signal. It is dependent entirely on the properties of the duct. See IREPS document. So that is a government document that is from the Navy, I believe. And yeah, so when it becomes infinite, then that means that the curvature of the Earth, that it's bending the ray such that it can get past any amount of the curvature of the Earth. And so you don't need to then have that as part of your future computation. All you need to then worry about is whether or not your signal is strong enough, is your transmitter transmitting well enough, and is your receiver going to be able to pick it up. So it simplifies some things, but modeling it doesn't make the Earth flat. It still isn't flat. So Rick to Bits says celebrating 3 human gestation cycles or CC's IQ. 3 human gestation cycles. So let's see that's 9 times 3, which is 27. Or CC's IQ, 27. Thank you very much, Rick to Bits, for 27 months. P. Barnes says celebrating 69 months of support. Yes, I'm a child. 69. Nice. Boston Concerts for $5 says, hold on, clean up, says it has finally hit me why MCToon looks so familiar after all this time. Dexter Holland, look it up. He asked for a 13, but they drew a 31. Dexter Holland. All right, hold on a second. Just a second here. What? Hold on a second. I could do worse. Hold on. I'll bring it up. Here we go. What it didn't update. What's going on? Hold on a second. There we go. All right. There's Dexter Holland. He was in The Offspring. Oh, I like The Offspring. I'm not familiar with the names of the people in The Offspring. Pretty fly for a white guy. Or pretty fly for a rabbi if you like the original Weird Al version. All right. I'll take it. I'll take it. Right there. Well, I got to get this off screen. There you go. I'll take it. I don't know. What do you think? Yeah, I can put on some sunglasses. Hold on. I got them. I got them right here. What do you think? All right. There you go. I've had these sitting on my desk for years. I think I've used them once in a video before. Just sitting right there. They're always right there. All right. There you go. Thank you very much, Boston Concerts. Hakraman says, good day, mate, and all the usual suspects. Thank you very much for that. Slithery says, I do love bending the frequency. Yeah. He lapsed into a little bit of his previous, after the 2 weeks of ChatGPT usage, previous nomenclature of bending the frequency, or we're getting bombarded by the frequencies, as if the frequency is the thing. No, it's not the right usage. Jack Vetter says, I was thinking of becoming an expert in a few different scientific disciplines in the next week or two, so I can cook Blitz too. Any suggestions? Okay, everybody. Jack Vetter needs to know what he needs to spend the next 2 weeks on with ChatGPT, of course, so that he can take down Blitz. Now, I know that Blitz's PhD has something to do with a little known, it's kind of a fringe idea that not many people have heard of, called general relativity, or just relativity in broader sense, by some guy. I think his name is Einstein. Anyway, he's got some background in that. So that's my suggestion, Jack Fetter. Just jump onto ChatGPT and say, I got 2 weeks and I'm going to spend 30 minutes a day. Teach me everything that I need to know to take down a PhD in this field. And I'm sure you'll be good. I'm sure you'll be ready. Anybody else, if you have suggestions, just tag Jack Fetter. I'm sure he'll be grateful. Unforticated says it's based on effective radius over actual radius, not pretend radius like his stupid presentation said. Yeah, so yeah, it did not look well in his presentation when he didn't use the actual like formula that was used in the in the literature. He substituted fake radius instead of effective radius. So not a good look. Not a good look. That's not how science is done. Tim Davidson says, I know a big G, ironically, his name is Jesus, and he steals hubcaps from cars. Ah, so it's not Jesus. Is it Jesus? He's a big G. I got it. Shedsy49 says, sadly, I have to go when this is getting so funny. Oh, well, thank you for being here, Shedsy. That reminds me, because Shedsy lives in the Minneapolis area. I've met him a couple times in person. I am, this summer, I want to do a meetup, and now that Ultimate Frisbee season is the busy season is wrapping up, I want to do a meetup, and so probably two, one like soon and one in the fall. So here's my question to all of you. If you live in the Minneapolis area, or you are within the distance that you'd like to travel here to do a meetup, where would you like to meet up in the Twin Cities area if you have an idea, a proposal, send me a message. You can email me, MCToon at mctoon.net. You can contact me on Discord or on Facebook. It's MichaelToon on Facebook. Just send me a message. One of those spots are the best. I suppose TikTok or X works as well. So a specific restaurant maybe you've been to and you think it's a good spot, something like that. I'll leave it open to anybody that has an opinion. Shedsy, in fact, one of the times that I did the cold moonlight thing, Shedsy had know of a field, a soccer field that was particularly good. It had an open view to the south, and so that's where we did that because he knew the area and suggested it. So anyway. That's out there just for whoever might be interested. So we got Jack Fetter says, the word flat appears on page 11 in the third paragraph, line 7. That's my citation. You've been cooked. Mic drop. Mommy said I'm smart. Oh, the Bag is a new member at Newton. Thank you very much for joining the Bag. It's an interesting name. I like it. Real Arnold says, maybe the song I'm writing about how much MCToon loves Pearl needs to be pop punk song instead of nerd rap. Oh my gosh. I do not like Pearl. Let's get this straight. Of all the programming languages, like I would write in Fortran before I'd write in Pearl. Though my very first web project that had a code to it other than just static HTML was in Perl. Yes, it was in Perl. There was nothing. There was no state keeping. There was no session. There were no cookies. The only way that you had to track something was to just modify absolutely every single URL to send the session information through the URL. And of course, this wasn't a you weren't logging in anything and you weren't sending any private information that anybody could hack your session. But you certainly could hack somebody's session. It wouldn't get you anything, but your session could absolutely be hacked because there was nothing. This was the Wild West. Yeah, it was in Perl. Fun fact: in order to track session, you only really needed to have a unique ID. But I went overboard and I included their IP address, right? Which you'd think and it was only a session that was for a few minutes. So somebody's on a modem, they redial, they get a new IP address. Right, that wasn't an issue, but it broke one day because AOL used a different IP address within the same session, and I'm like, crap! Why do I need to fix this? I don't want any of these AOL losers using our website. But the company's like, well, we do want the AOL losers using the website, so we got to fix it. So all I did was take it out because there's already a unique identifier in there. So didn't need it, didn't break anything, still worked. Anyway. Tim Davidson says, I recommend Weird, the Al Yankovic story. Great movie. I love it. Boston Concert says, Jack Fetter needs to learn to change a battery. Chirp. Icy Spin says, multiply my months by 18. I can't. So this thing here that I it doesn't tell me. It doesn't tell me how long. I didn't write it to capture. All I know, because I didn't see the super chat come in, and it's probably, let's see. Oh, there it is. I can see it here. Member for 37 months. There you go. Wow, that's a long time. I don't know why we're multiplying it by 18. 37 times 18? Can't do that in my head. Ah. Everybody do that on your own. Oh, so goofy. Mr. E-Man Original says a flatty sees flat, therefore flat. That's it. That's how dumb they are. Tim Davidson says, for $2, my ex loves hanging Five Guys at the same time. Having Five Guys at the same time. Not hanging. Tim. Poor Tim. Jack Fetter says, oh, and I'm going to spend a week learning Fortran so I can go back 30 years and cook Miami Vice tune as well. Hashtag reburn. I did Fortran. I did. I'll grab it in a second here. I'll get the book. I think I can reach it. Clem says, is that slide available? What slide? Oh, the slide that it was during our debate, and it's in the video, and it's like 2.5 hours, so I'd have to scrub through to find it. I don't think I could quickly find it. But somebody else could potentially find it and send me a screenshot. Then I could pop it up. But I can't. I really can't at the moment. Okay. So here we go. We're gonna go back. We're gonna have a listen to. I do have a stand-up desk now. Look at this. So you can read my shirt. I can. Yeah, I built the desk. I built the desk right here. It's I bought a 4x8 sheet of 3/4 inch thick melamine, and then I'm like, well, I wanted a little thicker than that, so I got another one 5/8 of an inch. Didn't want to go overboard and get 3/4, and I glued them together. And I like gluing stuff together like that because you just go in the garage and you find everything you can find that's heavy, and you just plop it on top. So I did that. And then I built around the perimeter. I'll get a picture sometime. Around the perimeter, I just put I cut it to, it's not 4x8. I shortened it a little bit. So it's 7 feet by 3.5. 3.5 by 7. And then around the perimeter, I just put so it's a 1x2 of the high quality pine from Menards from the toilet store, and then glued it and shot it with a nail gun, and then I just built some legs, and I guessed at how high to make it, and I nailed it. It's the perfect height. I love it. So I have my old desk right here, so I can sit down on it, but I don't sit down on it too often. This is getting choppy. Looks like it's... See that? Why is it getting choppy? Don't like that. Oh, Dick Wayne's here. Hi there. How many trips to Menards is the desk responsible for? 1. I planned it out pretty well. Okay. Here we go.
This guy says as low as 0.5, which is smaller than 2/3.
Oh, so somebody in your comments knows it better than us. Okay.
No, I'm looking at this isn't from the comments. This
I've never seen that, but I've seen 2/3.
This is the document that you told me about. How have you never seen this?
And not let me finish it? Are you really winning?
How have you never seen this? It's in the document that you told me to look up.
Let me finish. No, I've never seen that. Dude, are you gonna give me a chance to speak?
Go ahead, please. Explain why
I've
your
never seen that
document says
actually
this.
be used.
Okay. Are you a microwave technician?
I've never seen it actually be used. I've never seen it actually be used.
Are you a microwave technician?
They use 2/3, which would not...
In the in the 2 weeks of ChatGPT that he's got invested in it, he's never seen it used. All right, bro. You're so smart.
Be 0.5. What would 2/3 be, Blitz? It would be 66, right?
It's 0.66 repeating. Yeah. Are you a microwave technician?
Yeah, so it's not 0.5.
I'm sorry. Are you a microwave technician?
So in the actual efficacy
Are you a microwave technician?
of using these, I thought, are the actual efficacy
I
of
can just
using
turn you
these,
down
they
if you're
would
not
use
gonna
as
answer
low
me.
as 2/3 from what I've.
Are you a microwave technician?
Right.
Are you a microwave
So
technician?
it appeal to credentials automatically? Are you losing that
No,
bad?
I'm not appealing to credentials. Just answer the question.
Are you losing that bad? All of this that I had to teach you and you
This
asked
is
me for my
this
credentials?
isn't
All of this that I had to teach you in your 2 weeks of knowledge with ChatGPT and you're teaching Blitz. Oh, that's so adorable.
This isn't an appeal to credentials. I'm asking you because you said
You want
that
a
you've
secondary
never
source?
seen this done. Now, I'm asking what you mean by see this
I've
done.
never
If you're a
seen
microwave
0.05.
technician,
I've never seen
if you're
0.5. No.
if you were
I've never actually look.
what do you
I
mean
looked into-
seen?
Listen to me,
What do you
bro.
mean seen? Did you actually go out and like see
Listen,
how
I
the
will
calculations were
explain
done,
it to you.
or are you just looking up
Yeah,
like
you can't
the
ask
documents,
me a question
right?
and then monologue through it, bro.
You
Relax.
actually have to answer some questions sometimes.
Listen, let
Is
me
that
explain.
fair? Yeah, go ahead, please.
I'm trying to. You're not allowing me to. All right. It's so crazy, bro. You're actually getting cooked so hard.
Oh,
If
this
you-
is so embarrassing.
You look into the different formulas that
You're getting cooked so hard. I love it. He's so humble. Just like Witspit.
they use,
You're totally losing the debate, bro.
and I will source you different formulas that they use. I've never seen 0.05 be used in any of the specific transmission links that I've looked into. I've seen 2/3, I've seen 4/3, I've seen infinity, and I've never seen 1, right? Because you can't actually use 1. You can't use the true Earth radius value because we do have an atmosphere.
Now I have a question.
That's what the claim is. So they can't actually model it out. Was this all for modeling? You understand that,
Now
right?
I have a question, Soli. So, what do you
This is all
think?
for modeling, right?
Soli, question. So, what do you think is what are the conditions? And clearly, you know about this. What are the conditions in which
All right. My daughter just brought me this, which is a cookie dough ball with ice cream in it. So I'm going to be enjoying a little bit of cookie dough ball with ice cream in it. But I'll play that so you don't hear me eating it.
you would use 2/3?
If it was refracting upwards, I'd imagine you'd have to have low pressure and on the underneath, and then like high pressure above.
Okay,
That
and what are
would
the conditions
probably
where you would
be
use
what causes
4/3?
it. The opposite.
Okay. Now, is there a smooth gradient between low pressure above and high pressure below, and vice versa? Is that a smooth gradient?
All you're doing is giving credence to me not seeing 0.5 visible in reality, because we
Why
do
are
have
you
a pressure
avoiding the
gradient.
question?
No, I'm answering your question. You answered your own question.
No,
That's
it was
the
a yes-
problem.
it was a yes or no
you
question.
You don't see 0.5 in reality because the pressure
I'm not
gradient
getting at
decreases
that.
as you go up.
I'm not getting at that. I'm asking you a question. Is it the case that there's a smooth transition between high pressure here and low pressure here, and vice versa?
Typically, yeah.
Okay. So if there's a smooth transition, and it's that pressure gradient, according to you, if it's that pressure gradient that causes this, and there's a smooth transition in the pressure gradient, the intermediate value theorem from calculus would indicate that the K value, there is some atmospheric conditions where the K value is exactly 1, where that's what you would use.
I've never seen K = 1 be used.
Okay, but you understand that if there are conditions where K is less than 1 is used, and there are conditions where K is greater than 1 is used, then the conditions between
I've never
those
seen
two.
a condition where K = less than 1 be used.
I'm just asking you to think logically here, right? If we know that there are conditions where K is less
Give
than
me
1
an
is
example
used,
of K = less than 1.
please
me
use
an
your
example
noodle.
of it.
Use your noodle. Wait, you've already given me
No.
an example of where K is less than 1.
Yeah, that doesn't happen in reality.
Wait, you don't think that they ever use K is less than 1 in reality? Didn't you just cite an example?
No.
Wait, you said that you've seen them use K is 2/3. That's less than 1. Do you
No,
know-
I've
did you
seen
just
them
cook yourself?
state that it is viable
Yeah,
for intents and purposes
right,
in
so we're
modeling.
talking
they
about
don't use it in
modeling.
reality.
I
You're
don't
never
know.
gonna. Okay,
What
so
do you,
this is where
hold on,
you
hold
have
on.
to
What
let
do you
me
mean they don't
speak.
use it
You
in
have-
reality?
no.
We're talking about modeling.
You have to
Modeling
let me
and
speak,
reality
bro.
are like
You have to
you
let me
use
speak.
numbers and model.
You have to let me
You have to
speak.
actually listen
You
sometimes.
have
Okay.
to let me speak.
You have to
you
actually
let me
listen.
speak.
I'm
Please let
not.
me speak.
I'm actually going to address what you said.
I have to listen to you. You can't ask me a million questions and then not let me answer any of them.
Okay, I'll just turn you down. I'll just turn it down instead. So look, the point is that you don't use numbers to make measurements about reality. You use numbers to model reality. So of course you're not going to see K is less than 1 in reality. You're only going to see it in modeling because that's where the numbers are used. Numbers are used in modeling. So you've already agreed that you use K is less than 1 in modeling. You use K is greater than 1 in modeling for different atmospheric conditions. And so there will be some atmospheric conditions where you would model that with K = 1, and that follows directly from the intermediate value theorem of calculus.
So you can use, in reality, you might in cases use that where you're going maybe over water. Here's a great example. You say the water temperature is 25 degrees Celsius. And the air temperature just above the water is 25 degrees Celsius up to 10 meters, right? We have a rather consistent temperature of the air, right? And since the water temperature is 25 and the air temperature is 25, you're not going to get this. You don't have to where the water is a different temperature than the air, right? In that instance, yep, you could use one. You could use a radius of 0 for the, infinity is the actual value, right? For the radius of the path of light, or just straight line. You could. It's not that common, and it's certainly not common for a long distance. That's the real key here, because when you go a long distance, you're going to get the path of light or the path of the photons to go through different gradients. Now, I said that I was going to get my Fortran book. Here it is. I stepped away. You heard maybe some feedback a little bit because I turned my speaker up so I could hear when I was grabbing. Anyway, there's my Fortran book. This is the book I actually used at university. Since I was taking both engineering and computer science, I'm like, this was an elective. I'm like, well, this is exactly because I'm definitely going to be using this in my career, right? I've never used it, but and looking at this, I'm like, oh, people used to do complex stuff in this. It just doesn't lend itself. It does not lend itself to that kind of work. It's certainly not object-oriented. I would guess there is an object-oriented version of Fortran. That might be kind of fun. One of the things I did like about Fortran over C is that you specify the actual the precision of the variables, and in C they're like, oh, it's super portable because if you have a 16-bit processor, then int is a 16-bit, and if you have a 24-bit processor, int is 24-bit, right? They didn't have 24, but you know what I mean. And like, well, hold on a second though. I'm doing some math. I need to know whether or not the math will fit into the int. I need it to be an int 32. So I can't just use int. So all of this talk about C being so awesome because it's so portable, I don't care because I need the int to be 32 bits. Well, in Fortran, you tell it the size and it'll make it that size, and that's it. There's never variation. Anyway, that's beside the point.
Go ahead.
Can I speak now?
I did just say go ahead, did I not?
Okay, cool. I couldn't hear you. So, in modeling, yeah, but remember that the refractive index is supposed to be the value of K and that they don't actually change.
The coefficient of refraction, not the refractive index. He doesn't know this. The coefficient of refraction is due to a varying index of refraction. He doesn't even know that it is about a varying index of refraction. 2 whole weeks he didn't get that figured out.
The refractive index, when they model it out, they change the radius value of the Earth. They flatten it out, and sometimes they even bend it up, depending on how it actually, but I've never actually seen that be used.
Sometimes they bend it up. I've never actually seen it be used. Well, then how do you know sometimes they bend it up if you've never seen it used? And that would be bending it up 2/3.
But they can actually bend the radius value to make it convex, or concave rather, concave.
So just to be clear,
that is literally what K does. It changes the radius value of the Earth.
Yeah, it's to
in
make
modeling.
them. Yeah, exactly.
So in reality, this is where you have to interrupt me, right? But in reality, microwaves travel in a straight path. We model them in a
In reality, it does not travel in a straight path. Your citation contradicts you.
Straight path. We flatten the Earth underneath of it. That every single time we have to flatten the Earth underneath of it, regardless of what modeling mumbo jumbo mathematical nonsense we have to do. Doesn't matter what would you agree that you just got cooked, bro. Please.
No, this is hilarious.
Turn this around on me.
It's crazy to me that you think that this actually demonstrates that that microwaves don't bend, that they don't refract. Because if you use any k value that's not infinity, that implies bending. And you've already agreed that modeling is used where k is not infinity. You use k values of 4/3 and 2/3 according to you.
Infinity is used.
According to you.
Infinity is used.
I don't care how frequently it's used. Please don't interrupt. They do use 2/3 and they do use 4/3 according to you, which means that it must bend because the Earth, even if the Earth is slightly larger, or even if the Earth is slightly smaller, you said those things. You said that they use that
It's a straw man.
in modeling, which is what we're talking about here. They're trying to model a real world
this
thing.
is where you have to let me finish
so that
because you're misrepresenting.
you were interrupting me in the middle of my sentence and you're accusing me of not letting you finish. I'm sorry. Please try again. So the point is that if there is any
You're misrepresenting
again. I'm sorry.
my argument.
Okay, then you can correct me when I'm done. If there is any k that accurately represents the world around us that's not k equals infinity, that implies that there is some degree of bending. Go ahead.
Okay. In modeling, they use anything from what I've seen from 2/3 to 4/3 to infinity. They never use 1, which would be what you would use because they claim that 1 is when it bends perfectly around the Earth. Even though that what you claim is happening, they don't actually use it. It follows the true.
No. In infinity is in his usage of it is when the path of light matches the surface of the Earth. His index of refraction, capital K equals 1, is when there is no variation in the index of refraction, and the light travels in a straight path. That's K equals 1 in his usage of K.
Curvature of the Earth. 1 is when it follows the true curvature of the Earth. Yes.
No. That's not when it follows the curvature of the Earth. That's when it travels in a straight line, and the Earth is and it doesn't bend at all, and the Earth is just curved underneath it.
Man, Blitz hasn't spent 2 weeks on this, and he's nailing Soli on it.
1 would be representative. What's 1 divided by 6371?
It's 1 divided by 6371. It'd be some tiny number.
But that's not the formula. The formula is the effective radius of the Earth divided by the real radius of the Earth. The effective radius of the Earth is not 1. This is the instance where it's 6371 over 6371. The value of that is 1. The effective radius 6371 and the real radius 6371. My goodness, Soli, you suck at math.
Yeah.
What do you mean, yeah? Wait, do you understand that the algebra that's happening here?
Okay.
Like, if you take k as equal to 1, that means the effective Earth radius is equal to the true Earth radius. Do you understand that? Which means that in that case, the light would just travel straight, and the microwaves would just travel straight, and the Earth would curve underneath it, and it wouldn't follow the curvature of the Earth if k equals 1. You understand that?
1 is attributed to a true Earth radius, right?
When k equals 1, the effective Earth radius and the true Earth radius are the same.
Yes, got it. Okay, that's correct. Soli is not understanding. No surprise. Okay, but now unfornicated Dan sent me the slide of that the bro did during our live stream. So here it is right here. Where he says, hold on. That's not it. Hold on. Wrong one. Oh, jeez. I have 700 and something live streams. So this is, I got to get the correct one here. There it is. There it is. All right. This is where he says pretend Earth radius over real Earth radius. But the literature says effective Earth radius over real Earth radius. So this is not actual stuff. This is either ChatGPT generated where he instructed it to use that terminology, or maybe he wrote it himself. I don't know. I don't know if he's capable of writing this. But let's check. Is there a space comma? No space comma. So I'm not confident that he wrote this himself. Anyway, it says, instead of drawing a curved radio wave over the real round Earth, they imagine making the Earth bigger or smaller so the radio wave becomes a straight line in very narrow circumstances. The math still works. You just pretend the Earth has a different radius. Yep, that's a fine way to figure out the answer to the problem. The number that tells you how much bigger or smaller to make the pretend Earth is called the K factor. He used lowercase k. It needs to be uppercase. I'll give him some slack on that because he didn't have a damn clue about the topic because he isn't well read. He says if k equals 4/3, the normal value. There's no normal value. It's just the value that they use as an approximation in many instances. But it's not good over water in most instances. Over water, I'd use... I would use the lowercase k of 0.5, which is a different value. You pretend the Earth is 33% bigger than it really is. Why 4/3? Because in normal weather, the air bends the wave down just enough so you can draw it slightly over a slightly bigger Earth. Yep, no problem with that. Why is that a problem? It's not. He thinks that because somebody does some modeling that it makes the Earth flat. It doesn't. It's not how it works. All right.
That's
what it means when k is 1.
So that would mean that if it were to travel,
go ahead.
It would follow the, if it were to, okay, so if you have a transmitter and a receiver 100 miles apart, okay, you transmit a link, and those connect, okay, and you have a k factor of 1, that means that it followed the true curvature of the Earth.
No.
My goodness, he doesn't understand his own citation.
Oh.
That is what should be used 100% of the time.
That's not what k equals 1 means, no. I mean, we can go look at the plot, right?
Okay.
So
but now it's not.
So look at the plot. So here in green.
Wait, scroll back up.
Yeah, here.
K equals 1? Down.
Yeah. Here? Yeah.
To the diagram. Right there. True Earth radius. Wow.
Yeah. So let's look. Hold on. So here we have, if we emit at, say, 2,500, and then we have straight line trajectory, right? That's the green. Green is a straight line. It's just the path of light taking a straight line, not just taking a straight line as if there's no refraction at all. Then the final position is 20 meters higher than the initial position. That would not be following the curvature of the Earth. That would be going straight while the Earth curves below it, therefore ending up at a higher altitude. This seems like it's backfiring for you. Because I just don't think that you understand, like,
when they model
electromagnetic waves
they
here.
Literally flatten the Earth, bro. That is literally the argument. When they
But it doesn't make the Earth flat in reality, though.
model it out, they flatten the Earth.
I understand that, and that's because
microwave
microwaves will bend down in some scenarios, and so it'll be like the Earth was larger. They will travel as if the Earth is larger because of the refraction. Oh, the Joker laugh is not a good look if you're trying to not be thought of as crashing out.
So it'll be so much larger that it has an infinite radius value in some cases.
If you have total internal reflection, then yeah. Do you know what total internal reflection?
If you have tropospheric
I don't think he knows what total internal reflection means.
ducting, which is when this is used.
That's what total internal reflection is.
It's used in tropospheric ducting.
Do you know what total internal reflection is? I'll take that as a no. Look, so I agree.
No, and I'm breaking up again.
I can hear you just fine. Doesn't sound like you're breaking up.
You're breaking up then. I have red bars.
I don't see red bars on your connection. But it's possible. I can't see the red. For some reason, I can't see when you have red bars anymore.
Sully, if you're breaking up, you'd have to have a girlfriend first.
But look, I mean, this is a totally...
I think it's fixed.
Okay, so I'm glad that...
I answered your question. I said no, by the way.
Oh, that you don't know what total internal reflection is. Total internal reflection is when
Wow, that 2 whole weeks and he doesn't know?
you have a medium where you have some medium and then some external medium, perhaps, where the index of refraction is sufficiently different between...
So the index of refraction is sufficiently different. An index of refraction variation...
the inside of the medium and the outside of the medium, that you can't have refraction. according to Snell's law, to leave the medium so it just reflects. And so you would call that tropospheric ducting. Now, look, we can agree to disagree on this. Why don't we just go look at something that doesn't have any refraction at all, and we can agree on that, and then we can just go look at what shape the Earth is using that kind of method of taking measurement data.
That sounds like a great idea. I'm sure that a truth seeker would want to know about that.
Would you agree that the only variable that they actually use and fluctuate is R? Like,
I don't know why you're ignoring what I just said.
Well, I just want to be on the same page with you for once, right?
I'm trying to be, but you didn't answer what I just said.
The only variable in I'm trying to level with you, bro.
Did a car just start? Where is Soli? He's got motorcycles driving by. He's got a car that just started. His laptop's only at 33%, and apparently not charging. Where the hell is Soli right now?
I literally asked you a question, and you're just ignoring it completely.
Yeah,
you're not
if
trying
the
to be
only
honest
variable
here.
in the equation, if the only variable in the equation that they actually change is the R value.
But that's not the only variable. They vary the frequency. They vary the power output. They vary the gain of the antenna. Right? There's all sorts of things that can vary in this.
Consistently, whether it be in plane surveying, they do the same thing with plane surveying. They use 7/6R as well.
Oh my goodness. No. Oh dear. In plane surveying, I don't think he knows much about plane surveying. Right? Flatties just, they see a quote and they don't quite understand it. Anyway, here is surveying 8th edition. I've got it bookmarked here. Just a quick thing here. Where'd it go? I got a $2 bill as my there it is. Here's the bookmark, the $2 bill. Right there. You see this underlined part here? It's on page 3. The surveying operation in leveling takes into account the curvature of the spheroidal surface of in both plane and geodetic surveying. The leveling operation determines vertical distances and hence elevations and differences of elevation. Typically in plane surveying, you're not doing a long enough distance where and the techniques that you use in most differential leveling negate both the curvature and refraction. They do this by measuring forward and backward from one theodolite or auto level, right? And you keep that forward and backward distance the same so that the curvature on both sides is the same and the refraction on both sides is the same. Now, of course, you can have a variation in the refraction if you're going over a surface that is different on either side, significantly different. But keeping it a short distance helps that because both curvature and refraction compound with longer sights. And so when you're doing a short sight, say you're doing 100 feet in both directions, well, the amount of refraction that you're going to get is nominal, and you don't get a compounding effect in the second chunk of 100 feet, right? It's not 200 foot, it's just 100 foot. So anyway, good morning, conspiracist.
Then that's not a constant. You can't claim that the radius value of the Earth is constant. You literally have to fluctuate it to make transmissions work.
He's so dumb.
Mathematically.
Shut up!
What?
Why can't you just answer my question?
Why can't you agree that the only variable in the equation is the R value?
I'm not going to agree to anything. I'm not going to answer any of your questions until you can answer mine. Sorry. If you want to engage honestly, you have to be willing to answer questions on occasion.
Is the R value.
That's a cool claim. Now, you want to address my question?
The only variable in the equation is the R value.
Oh my god, it's like a broken record. Somebody poured water on him? What happened? Do you want me to ask it again?
Proceed.
He has a script. He was given a script. He doesn't know this topic. He spent 2 weeks on it. and he thinks he's an expert. He might be the foremost flat earth expert on this topic. Very likely could be, right? 2 whole weeks plus ChatGPT. That may be the most dedication any flat earther has ever dedicated to a topic, right? That's why he doesn't want to change the topic here, because he's got that script and he's just got to punch through it, just shove it through.
But I'm not going to change this topic. You want to run away from this. That's what's happening. You want to run away. I'm not letting you. The only variable in the equation is the R value. Why is that?
He's like a broken record. He just keeps saying the same thing over and over again.
Why is it the only variable? Since when does the R value become a variable in an equation? Why is it not a constant?
It's lovely that you want this question answered. To be clear, I have actually answered this question already in the past 15 minutes, but I guess you didn't pick up on it. I asked you a question and you are hilariously running from it. You're like, put on your running shoes, you got onto the track, and you're just sprinting away from it as fast as you can because you know that you'll lose if we talk about anything besides microwaves. You know that you'll look even worse than you're currently looking. Like,
That's hard to do.
I have now spent
I don't think I look all that bad. To be honest, I think I taught you quite a bit.
To be clear, I've spent 40 minutes with you talking about microwaves, and I still know more about it now than you did coming in, because apparently I can actually understand these equations much better than you can. You thought that when K is 1, that meant that the effective Earth radius was 1 and the true Earth radius was 6378 or whatever. That's not what
He's being the flirt whisperer here.
it means for K to be equal to 1.
Division of the two.
Yeah, clearly. And an effective Earth radius does not mean, an effective Earth radius of 6378 does not mean that the electromagnetic wave would follow the curvature of the Earth. That's not what it would mean. In fact, the K value says, it describes it right here for us. In effect, the bending of the beam either up or down makes it appear as though the radius of the Earth is less than or greater than the true radius. That's because of the bending. It's not actually greater than or smaller than the actual radius of the Earth. It's that the bending of the beam makes it look that way. So that's why effective radius is changed in the equations, because that's how it appears to be due to the bending of the beam. Now, we have spent 45 minutes.
But when we model it, we don't bend the beam.
Oh my gosh.
You can do one of two things.
He's so dumb. He's so dumb.
I know you quote unquote answered that already.
You can do one of two things. You can either make the Earth bigger and not bend the beam, or you can keep the Earth the same size and then bend the beam. They will give you the same answer.
The question that they're trying to answer, that Blitz is getting at here, is how far will the transmission go? It doesn't matter how you model it. All that matters is that you get the right answer. It's one of the things that I tell my kids when it comes to math, right? And physics, really, science, because we homeschool our kids. So I want them to be able to solve problems. And one of the things that you're being taught in math is how to solve problems. So when they get, here's what you need to do for math. How did they get to the point where they understand the topic? I don't really care. They could read the book, they could watch videos, they could just figure it out themselves. They could read the answer key, understand what the answer key is doing because it's running through the steps, and then figure it out themselves. I don't care how the answer is obtained, how the result is obtained. What I want them to do is to understand how to do it, understand the topic. Now, I don't want them to just get the right answer. I want them to know how to get the right answer. So just looking at the answer book and writing down the number, that's not the goal, right? They didn't learn how to do it. They just learned how to write the answer down. That's not the point. And of course, flat earthers, they're just trying to write down the answer, right? They look at a document and they just search for flat earth. They're like, oh, flat earth, that's the answer. Boom, I'm just going to write it down. They don't have any understanding of that document. They don't know what that document is trying to do. They have no clue about it. And same thing with Soli here. He's like, I figured out the answer. And to him, the answer is how to get street cred in the flirt circles on TikTok. That's the answer he's looking for. how does he get street cred amongst the flurfs? Sound bites. That's how he does it. And so he thinks that he can chop this up to make it look like somehow he's coming out better than Blitz. Now, to people that understand the topic, like, oh no, you did not look good there, Soli. This is not a good look for you. You're clearly an idiot. You're out of your league here, and this is nothing good for you at all. But when he can control the narrative and he can clip it up and he can play it for his buddies, then they can all pat him on the back, and without understanding what the whole conversation was about, say, you did so good. You're such a good boy. That's all he's looking for. He's looking for the answers. He's basically just going to the answer book and trying to write it down. The problem is, you're doing section 15, right? But you're writing the answers down to section 13. And they're still wrong. And it's not even just section 13. You're doing middle school algebra. Yeah, middle school algebra. That's section 15, middle school algebra. But you're writing down the answers to section 13 from elementary school addition. It's not impressive.
Why don't we do the latter then?
Because the latter is much more complicated
It's not that
numerically.
much more difficult of a formula.
Is. It really okay. What's the formula for it? Tell me.
Like I said, you would take your derivative of P over your derivative of temperature, probably?
No.
Right?
Your derivative of the pressure. Wait, hold on a second. Pressure, you only have one value there for pressure. So what's the it's a constant. What's the derivative of a constant? And you have temperature, and it's just one temperature, right? And what's the derivative of a single value? Oh, hold on a second. That's not going to give you anything. He doesn't know what a derivative is.
Or derivative of height, maybe. Derivative of height?
Derivative of height.
Nope.
Pressure over height?
Oh my gosh.
Nope.
No.
You tell me.
No, he's the one claiming that he knows the formula.
So there's a general way
I
that you could do
understand
this.
you would have to know the...
You need to know the variation, right? You need to get the formula for the variation in the index of refraction. And that you can derive from pressure and temperature, right? So you can create a formula that includes pressure and temperature as they vary over elevation. So you need to have them in there. I don't know where you're going to get these values from, but whatever. And that you need to build a formula for. And then once you have that formula, and he doesn't even know what a formula is, then you can start talking about taking derivatives. Oh my gosh. He's so lost. Blitz, absolutely brilliant, getting him to pretend like he knows about derivatives.
The frequency.
There's a mildly, but we can even ignore that.
Wait, what about the frequency?
So there's a general way that you could do this.
I understand you would have to know the frequency.
There's mildly, but we can even ignore that.
Yeah, the frequency isn't going to have a huge impact on it. Frequency does, right? The amount of refracting that happens does vary with frequency. But, this is 868 megahertz. It's not going to be a ton different than 2000 megahertz.
There's a general way that we can do this. You would take the covariant derivative, which is in this case in spherical coordinates or in polar coordinates if you want to work in two dimensions, of the index of refraction times the path variable. And you would set that equal to you would take the covariant derivative of the path length, the path length vector, like dx d lambda or something like this, times the index of refraction, which
dx d lambda. And what did Soli just hear when he said dx d lambda? What do you think Soli heard?
is a function of position, and you set that equal to 0. Now that is a nonlinear partial differential equation. Good luck. Good luck solving that. I mean, it's doable. You could solve it numerically with an annoying like a numerical calculator, but it'd be a pain to do when you could just multiply the true Earth radius by a single number and then solve it as you would normally do it while treating the index of refraction as constant. Like makes it so.
Yeah, it's basically middle school algebra versus pretty serious university level calculus, because you're not just dealing in Cartesian coordinate systems, you're doing it in polar, partial derivatives, partial differential equation. That's probably junior year of university would be where you'd just be getting into being able to deal with that. And I can tell you for certain, right now, like I went through this, I could not even touch this right now, actually doing that work. It's really difficult. I can see how incredibly difficult this particular problem would be, right? And when you look at, when you look at what's his name? The guy that did a ton of this work. I've got his name. Quantum Eraser. Could you help me? What is the name of the guy, Quantum Eraser, that is the expert in this particular field?
The subject matter expert, Andrew Thomas Young, our favorite guy.
That's right, Andrew Thomas Young at University of San Diego. So you go to what he wrote, and you can find his pages on the University of San Diego webpage, where he actually has a bunch of citations, including how the coefficient of refraction was derived using calculus. And so what you do is in calculus, you don't always go to the full complicated version. You apply calculus so you can have the simplified version that you can go and take and apply to actually solve the problem, right? So you don't need to take the actual, right, basically infinitely short path lengths over and over and over and over and over along the whole path. That's the point of calculus. It'll output a way that you can use it simply, and that's how you get the coefficient of refraction. Andrew Thomas Young. Tell me again about, what was his name, QE?
Andrew Thomas Young, San Diego State University, Astronomy Department.
That's right. Thank you.
Subject matter expert.
Yes, they got it. Thank you.
So much easier. And yet you're saying, oh, well, we can just solve a partial differential equation. That's so much easier than just solving an ordinary ODE. I guess an ODE is already ordinary.
Well, of course, but my claim is it's not.
He doesn't know.
Of course, you don't know what either of those things are.
Original or ordinary differential equation. Yes, I know what an ODE is.
Okay,
yeah.
Proud of you.
Let's slow down here, bro. It's like.
Have you ever solved
high school
one?
level math. Yeah, I had to do it when I was doing this. Yeah.
Oh, okay.
Wait, he claimed that he did it, I think, right? Let's listen again. Did he say that he's done it?
School level math. Yeah, I had to do it when I was doing this.
Hold on. Something level math. I want to hear what he said there.
Differential equation. Yes, I know what an ODE is.
Okay.
Yeah.
Proud of you.
Let's slow down here, bro. It's like.
Have you ever solved
high school
one?
Level math.
High school level math. Differential equations are not typically high school level math, right? Now you can take calculus in high school, but it's not normal high school math. I think for the most part, you're going to have, as a freshman, you're going to take algebra 1, then you're going to take geometry, then you're going to take algebra 2 your junior year, and then your senior year, if you take math, which in some school districts it's optional, you would take pre-calc, or they may have a different name for it depending on the school district, or calc if you tends to be. So what I did is I was in enriched algebra 2, it was called, and then calculus was next in high school. My senior year I took or enriched or advanced, I don't know what it was called, but it wasn't AP. I didn't take an AP class. I didn't get college credit for it. But anyway, I'm sure. Yeah, he's probably just like Witzbit, like super good at algebra. But do you have a model?
We don't have a model.
I didn't think you had a model. Austin, after all this talking with you, what do you feel about
wow, bro, you just made me look ridiculous.
Yeah. Thanks.
Yeah, I had to do it when I was doing this. Yeah.
Oh, okay.
When I was doing-
which
I
ODE did you
debated-
solve? Which ODE did you solve? I'm curious.
For atmospheric refraction, just simple ones.
Oh, okay.
Atmospheric
You want
refractive index.
so the atmospheric refractive
The refractive index. Nope. That's not it.
index. So you solved the. Okay, yeah, sure. But you
It's
didn't
like
solve the trajectory here.
0.77. You're gonna get me off. You're gonna get me off guard here, but it's like 0.776 times pressure over temperature, and then you either add. I think you add 0.3. You have to get the water vapor divided by the temperature squared.
So he cited this formula that he most certainly did not output himself in our debate.
And then you need a derivative of temperature and over height. Temperature and output of temperature over input of height.
And how did you solve this differential
would be your
equation? What method did you use?
It's math, bro.
What
I didn't
method did you
actually
use?
do it, though.
Oh, you didn't.
I filled in the blanks with like arbitrary, like 30 degrees Celsius.
Oh,
100
okay. So you
Fahrenheit.
didn't solve the differential equation. You just plugged in
it's-
values
it's-
and you didn't actually solve it.
He plugged in
Yeah, that's how math works, bro.
No, it's not.
he plugged in values to an algebra equation that was a freshman in high school level algebra equation. Right? He's like, that's how math works, bro. A guy who can't do math talking to a guy who's a PhD and certainly did a massive amount of math. Oh dear, the hubris.
You do plug in values and you do just solve things. That's typically
solving
how
a different
I'm gonna puke. It's so funny. Oh my gosh, he's trying to talk in a condescending way about how math is done.
differential equation isn't just plugging in values. There's actually like a process to solve a differential equation. There are things like you can use integration. You can use constants of integration to solve second order differential equations, for example. You can integrate both sides if you want to solve a first order differential equation that's separable. Like, there are methods. I was just asking you what method you used, but I don't think that you actually solved the differential equation at all.
Okay. Does that make the Earth a ball?
Cope.
Well, it makes your critique a little bit, like, kind of fall on deaf ears, because if you don't know what you're talking about, I'm not really sure why I should care
I feel
about
like I
this.
increased your viewer count by quite a bit. I'm not gonna lie.
People love to see me cook, but also to be
Yeah,
fair,
they
you
like to
did
see me
join.
cook it,
You
bro.
did join right as I started, so like people were going to trickle in anyway. But like, look,
Pretty
so
sure I haven't seen you with anywhere near this many views in months.
I
sure
had
you're falling off,
1,200
bud.
views last week when I was live doing the same topic.
Aw, he thinks he's special. His mom says he's special.
Okay.
So that was 300 more. But
Well, so only when you debate flat earthers do you get views. That makes
people
sense.
like the flat Earth content more than the creationism content, because creationists tend to be fewer and further between, and
I'm a
people don't like
creationist.
philosophy very much. That's a shame. Look, so Soli, you know what would be great, and you know what would make things a lot easier. So, hopefully you now grant that solving the differential equations involved for a spatially changing index of refraction for a particle of, a beam of light traveling through the air can be fairly complicated, and you don't like that they just make the Earth change its size miraculously to account for that fact. So, instead of doing that, why don't we just work with something that doesn't have any refraction at all?
Dude, if you want to change the topic, you can.
Well, we're still going to talk about. We're still talking about beams. We're still talking
48 minutes on one topic, and it's very clear that Soli is significantly outclassed.
about figuring out the shape of the Earth by the way that the beams travel. It's the same thing. It's just we're just going to use something that is, a more controlled variable, if that's fair.
I mean, sure, bro. You're desperate to bring up something you have overwhelming confidence in. I'll give it to you.
I now have overwhelming confidence in this, not because I'm an expert microwave technician, but because clearly you have way less knowledge than you thought you came in with, and so I'm confident that I can come to the conclusions
argue that
correctly.
100%.
Less than a month of research into this topic, I'm pretty well planted in my feet. I would argue that I did pretty well for someone who's been studying this for about a
Not
month.
really.
No.
Oh
Anyway,
no! I was
should we
able to
talk
go
about-
toe to toe with you, and you. This is
He did not go toe to toe. Oh, Soli, you got absolutely demolished. You're so wrong.
your profession, and I was able to go toe to toe with you, but I didn't do very well.
No,
Mr.
you didn't
Ego.
do very
That's
well.
cool, man. Oh, okay.
Anyway, so
I had to teach you what cave.
So now it's a month, right? 3 days prior, 4 days prior, it was 2 weeks, and now it's a month. Amazing.
The factor of K is. Yeah, that's cool.
well, you didn't tell me it right. This website did.
You thought it was little K.
You thought it was
little K.
You
but
thought
okay.
it was index of refraction. By the way, actually, just as a check, the refractive coefficient that I was using, which is referred to as little k, that I was referring to, is the same quantity, by the way. So this is a paper that I was referring to where they measured the index of refraction.
K versus K.
Here. So here's the table. You have.
What is
this
it you're saying?
So this is so they call it little k, but it's the exact same quantity that you're calling big K. It's the effective Earth curvature radius divided by the true Earth curvature radius. So little k and big K are identical in this setting.
Formulas to derive them.
No, it's the same formula. I mean, like it's effective Earth curvature radius
Can you
divided by
scroll up
true
a
Earth
little
curvature radius. Yeah, sure. Where?
Back down. No, you scrolled past the part. That's interesting. A little bit more. Oh,
Here?
no, that's not
This
down.
guy?
Blitz. Oh, now you're lost. Now you don't know where you are.
Here?
Oh my
Where do you
gosh.
want? Do you want
No,
further
there was a
down
graph
below?
there somewhere.
There's
Right
yeah,
above
there's-
it.
Here?
Right above it. Oh, the one part that you won't show. Isn't that interesting?
I have no idea what you're talking about. Which
Oh
part?
my
Do
gosh.
you want me to scroll up or down?
So desperate.
Can't even make most of that out, to be honest. It's a little blurry.
I can make it bigger. You should have said something. How's that?
Go up a little bit.
The part you won't show, but how do you know what it is? Because it's too blurry.
Hold on, let me just make this slightly bigger on the other streams as well. There we go. Okay, up a little bit. Rolling. This one? This graph?
What is this representative of exactly? The value of K?
Yeah, well, not this graph, the ones further down that
Like
I
how
showed you
it's
just a minute
derived?
ago. No, these are just measurements
Measurements.
of the value of K.
There's a lot of ways to derive K.
These are measurements,
Like,
not
like in
mathematical
standard
derivations.
refraction, you don't.
These are measurements, not mathematical
standard- I'm
derivations.
In standard refraction is the value for K that is used in the base case for normal conditions. That's what standard refraction means. If you measure it, you wouldn't use standard refraction. You'd use the measured value of it.
Sorry, plane surveying, you do different.
Yeah, so like
What was
here-
your other topic?
yeah. Yeah, so have you ever heard of neutrinos?
It wasn't going well for him.
Yeah, have you ever observed one?
No, I also have never observed like a bacteria, but you know I know they exist.
Oh. Well, I've never observed the curvature of the Earth, and I don't think it exists either. So,
I didn't say that I don't
well,
think
it's
it
weird to
exists
bring up
because I
something that's
didn't.
not observable.
Well, I mean, like we can detect them, we
Weird,
just
weird.
can't see them with our
That's a weird
eyes,
thing.
right? There are a lot of things we can't see
You
with
detect
our
the
eyes.
probability of them. You detect the probability of them.
Oh, this is going to be really awkward for you. No, you don't detect the probability of them. You detect them directly. They smash into things, and you see light
How?
that is emitted as a result of them smashing into things.
You sure?
Yeah,
How do you know it's a neutrino?
because we can measure the charge of the things that come out. We can measure the trajectory and its
How do you know
influence
what's,
on the
how do you know
on the
what's
magnetic
causing it,
field.
where it's coming from?
How do I know what's caught? Well, you can
Because you isolate.
turn off the source, and when the source turns off, the detector stops detecting things.
Do neutrinos have charge?
The Rebel Raider said, "Have you turned on gifts so we can spend our gems on you?" What is this this sorcery you talk of? Gems? Hold on a second. This isn't a TikTok thing, right? TikTok has like gems and stuff that I don't understand how that works, but hold on. I don't. I'm looking right here, and obviously I haven't. Gifts. Turn on gifts. Oh, let your fans join the fun and be part of your stream by sending you gifts. You'll earn rubies each time you receive a gift. Okay. I've read it all in detail. There we go. Gifts are now enabled. All right, there it is. I thank you for asking me. Now you can, whatever that means. I don't know what that is, but if you do, and I get a notification, I will thank you from the bottom of my heart. All right, getting back to this screen here. Okay, back to this. Thank you for reminding me. I'd seen it come through, but I didn't do anything with it.
No.
And then how does that work?
How does what work?
How do you detect light from something that doesn't have charge? How does it how does it transfer energy?
So they smash into things and they interact via the weak nuclear force.
He thinks the only way that things interact is charge. Aww.
Based on what evidence?
Basically all of particle physics starting in the 40s up till today.
Based on what evidence? He's gonna just... Oh my goodness. I just got a... Do you see that? A UNC alert from the Rebel Raider who sent a gift. Awesome. Thank you. I don't know what that means, but thank you for it. There it is. Sent a UNC alert. Cool. I gotta figure out what those mean now. Did it show me something here? It just says, give a heart there. Okay. Cool. Thanks.
Like, do you want
particle
the
physics is entirely
wait? So just to be clear,
okay.
you want the evidence that they interact via the weak nuclear force. You want the evidence that neutrinos exist. What do you want the evidence for?
This is your claim. I'm wondering how it proves that the Earth is a sphere, to be honest.
I'll show you. I will show you, and then you're going to try to nitpick it, and that'll be fine. We'll have fun doing that. Okay. So.
Do you mean I'm going to ask you questions about your claim?
No, questions are fine.
I didn't realize we were in a debate.
Questions are fine. Let me just find.
Just Sully, just so you know, denying the existence of neutrinos is not going to be a win.
The right chart, and let me find some useful diagrams that will be instructive. This is on section 3.3. 1 sec. I'll show you in a sec. I just want to pull them up.
I heard birds in the background. See, I think Sully's outside, right? Which is great. I'm glad he could be outside. But is he outside because he doesn't have an inside to be in?
3.3. There it is. Okay, so there is a particle beam. There's a particle collider, in fact, in Fermilab. This is near Chicago. It's just outside of Chicago in Batavia. It's called Fermilab. Surely you've heard of it. It's a pretty big deal.
No.
Yep.
He's never heard of Fermilab. Never heard of Fermilab.
Heard of Fermilab? Okay, well, it's
not that big of a deal. Nope.
I mean, it was a several billion-dollar project, so I kind of assumed that.
Yeah. So is child trafficking.
Okay. Anyway, so it's a national laboratory in just outside of Chicago. They have particle colliders. They run a lot of different experiments, but one of the experiments they run is something called the Minos experiment. And what they do is they produce a beam of particles that decay into neutrinos, and then they shoot those neutrinos across a very long distance to a place called Sudan in Minnesota.
Now, this was decommissioned a few years ago. I have toured this mine. So there's still a mine in Sudan that you can tour, and you go down the elevator and then you go down the elevator and then one direction, like, yeah, this gate here is where that particle detector was, and it's fenced off underground. There's a fence, right? It's in there. And but we're gonna go on the mine over here in the tour. So we went on the tour. I was all giddy because it's just close to where the particle detector was in Sudan, the one that Fermilab was sending. And since then, they've moved it to a deeper mine in South Dakota and in the Black Hills. And the reason why they moved it is because the distance between them, if you look at the map here, the distance between them, the neutrinos take a certain amount of time to travel that distance. And the hypothesis is about that neutrinos will vary their flavor between electron neutrinos, tau neutrinos, and muon neutrinos over time. And so what they do in Fermilab is they send out a very particular type of neutrino. And then when they measure it in Sudan, they're testing whether or not a certain percentage of them, hey, flow state. Awesome. Thank you. Flow state. I don't know what that is. So they change over time, and so that particular distance was enough, and they were able to measure the percentage of them that changed the flavor over time. And so then they're moving it to South Dakota, a larger distance away, so that they can test the hypothesis that it will then vary as a larger percentage into a different flavor of neutrino. So that's the hypothesis that they're testing. Very short, to my understanding, probably got some details wrong. Take it as an overview and go look up the experiment on your own if you're curious about it. It's really cool. I'm hoping to go tour the active one in South Dakota at some point, but I don't have any near plans.
It's 730 kilometers away, something like this. Yeah, 730 kilometers away. Now, the reason why this is relevant for the shape of the Earth is that if the Earth were flat, you would think that you would just have to, let's say that your beam of neutrinos started out on the surface of the Earth, and your detector was also on the surface of the Earth. You would think that you would just point it straight, right? You would just point it straight along the ground, and then you detect them at the detector. Now, if the Earth was curved, what you would expect is that you would point your beam down into the ground, and then your detector would pick them up coming up from the ground. And indeed, in order to make these detections happen, the particle beam has to aim into the ground at roughly a 3-degree angle, and the particles are detected in Minnesota coming up from the ground at a roughly 3-degree angle. So the particles are going like this. If the Earth was flat, the particles are traveling straight if the Earth is a globe. And the funny thing is, neutrinos, they don't refract at all. They're not charged. They travel in a straight line, right? So, if they travel in a straight line, we need to explain why it is you have to point them down into the ground in order to be picked up coming up from the ground somewhere else 730 kilometers away. And this experiment is like a thing that exists. I have data for you here.
Can you show me a neutrino?
Can you show me a neutrino?
Is that going to be the sum total of your argument? No, like you can't see neutrinos with your eyeballs.
Yeah.
Oh, his microphone mysteriously stopped working again.
You can't see neutrinos with your eyeballs. They're not photons. You can only see photons with your eyeballs. You're breaking up again, by the way.
Oh my gosh. This is not going well for Soli here.
You there?
Yeah, I know. Photons may or may not exist also.
You can see them directly, so they definitely do exist.
The desperation.
It interacted or does not interact?
Sorry, one more time? You cut out.
You see light. How do you prove that it interacts or does not interact?
That neutrinos interact or don't interact?
Do not interact.
Well, so they do interact. They just don't interact via the electromagnetic force. They don't have charge. Yeah. They interact via the weak nuclear force. It's just rare.
Right.
Wow, it's nothing.
This seems pretty trust me, bro. I'm not gonna lie, man. There's not a lot of like, what are you showing me?
I'm showing you data.
How does this prove that the Earth is
Oh my god. Is this an anecdote?
curving?
This right here. So, and I'm happy to explain this. So this is the data for this particular experiment. And so we can just look at the actual thing. So this is neutrino background here. That's the NC. That's that.
Yeah. So when the neutrino transmitter is off, there's your baseline, the NC background.
See those gray bits there? That's what they expect, and that's what they measure when the neutrino beam is turned off at Fermilab, which is over in Illinois. And then when they turn it on,
that's probably at Sudan actually.
Get
right?
All of it's the black dots that are fit with the red lines, the red bars. And so clearly there's a correlation between doing something in Fermilab and something being picked up in Minnesota. They turn one off, you get no signal. You turn it on, you get signal again. So there's a correlation there. And regardless of what
correlation, established causation.
I wasn't done. What this is doing is it's establishing that there's a relationship. In this case, yeah, because you have a way to control the correlating factors, right?
Yeah, that's science. You have an independent variable. The independent variable is turning on and off the transmitter. When it's off, you don't get these signals. When it's on, you get these signals. You've confirmed the cause of these new signals. Oh my gosh.
When you turn one off, the other one does turn off. Sorry?
Any chance you can send me this?
Yeah, it's freely available. I'll just show you the link. You can take a screenshot if you want.
Hold on, let me get a. Can you zoom in? There you go.
I'll show you the link for the other thing too. The other one has a little bit longer of a URL, so I'll have to make it a little bit smaller. But one sec. How about that?
Yeah, zoom out a little bit. Yeah.
All right, so my screen did not freeze. We're not actually seeing the title of the paper in the video. Blitz made a custom version of this interaction today. When I was talking to Blitz, I'm like, hey, I'd like to cover your interaction with Soli. He's like, hey, I'm making a video, a standalone video for this instead of the live stream, because the live stream was 4 hours. So, and if you could you link to that one? I'm like, yeah, absolutely. And so I'm watching that one and link to it. I actually downloaded the full one and then used Handbrake to chop out just their interaction. But I'm using this version that Blitz made instead of the one that I chopped up, because the one I chopped up is tall. It's vertical. I didn't get the horizontal one, and I know he's streaming on multiple platforms, so I didn't get the horizontal one on YouTube. I only got the vertical one. I was kind of in a hurry. I had to leave, had to come back. I walked into the house about 5 minutes before 10. And so I was in a bit of a hurry just to get it going. So I'm super happy that Blitz did this version of it. Anyways, thanks to Blitz. He's awesome.
Got it?
Okay. Invisible things don't prove the Earth is curving. I will say that.
Lots of things are invisible. Do you think that you can see wind?
Oh, look at that. He's so confused.
Can you see ether?
Yeah, you can see the effects of wind.
You can see the effects of wind. You can't see wind.
You can see the effects of neutrinos.
You can see the effects of neutrinos.
But you can see, well, technically speaking,
Blitz and I, we share a mind.
Like,
I wish. He's way smarter.
If you have fog, right, which would still be an effect of wind, like you would have fog moving.
Fog is an effect of wind.
But
but you can't see
ether
wind.
Can be detected.
Ether can be detected.
Got like a 4 kilometers per second.
Wait, oh my goodness. Paul Schober, exactly. Can you see microwaves? That's the third law of Flurf, the inconsistent standard of evidence. Right, as it's phrased, it's a little different, but the point of the third law of Flurf is they have a certain standard of evidence that they'll use for their stuff. You can't see microwaves, but he's okay to use microwaves. You can't see neutrinos, but he's not okay using neutrinos because you can't see them.
I'm sorry, can you see it? Or are you just seeing its effects? Because what we're seeing here is we're seeing the effects of neutrinos.
So do you believe in ether now?
No, I don't believe in ether. No, I don't believe in ether, because we have scientific experiments that rule it out.
Oh, but it can be detected.
I don't think it can.
It can be detected.
I don't think it can. I think that you think it can.
Oh, really? Like what?
But even in your...
Like what?
the entirety of special relativity and all of the evidence in favor of it.
We ruled out ether. How did we rule out ether? How did we rule
with
out
special relativity.
How did we rule out ether?
With special relativity. All of the experiments that are in favor of special
like
relativity.
Lorentz contraction?
All of the experiments that are.
So Soli realized that he was getting absolutely humiliated and demolished on this topic. And so he's grasping onto any straw that he can to save him from this topic that's completely ruining flat Earth, because he knows there is no rebuttal to this. There is no knowledge. He doesn't have the knowledge of it, but he's just super uncomfortable because he's not interested in the truth. If Soli were interested in the truth, he'd be looking at this saying, oh, well, what do you know? They had to angle that beam down at 3 degrees, and it came up at an angle of 3 degrees on the other side. Amazing. That is very good knowledge to have. And it tells us a lot about the shape of the Earth. But instead he's like, can you see neutrinos? Good job, Soli. Good job being dishonest.
In favor of special relativity are evidence against the ether. But look, before we can talk about the ether if you want. But my point is,
no. You want to talk about? No, I want to talk about this.
We can talk about it in a second. I just want to put a pin on this. Is that okay?
What disproved?
I just want to put a pin on this really quick.
Oh, he just keeps going. He's like, help, how do I get out of this?
I just want to put a pin on this really quick. So the point is that we have that, like, we agree that there are things that exist that you can't directly see, and instead we measure their effects, like with wind, and in your view, what you think the ether is, right? We measure the effects of these things, and then you can infer that they exist. And so what we're doing here is we're measuring the effect of the neutrinos, and through the last 70 years, basically, we have inferred that these things exist. They have certain properties. We know how they behave pretty well. There are still a few questions, but we know how they behave pretty well. And so now, this particular experiment wasn't about proving the shape of the Earth. It just happens to do so kind of just by accident, because they have to shoot this neutrino beam into the ground at a 3-degree angle. And when they detect it, it comes up and out at a 3-degree angle. And neutrinos aren't the kind of thing that bend. They don't refract at all, and they can pass through solid material of thousands of kilometers thick. So we need to account somehow for this fact that somehow the neutrinos seem to be bending, despite not actually ever bending in any experiments we've ever seen, if the Earth is flat. Alternatively, the Earth can just be a sphere, and they're traveling in a straight line, as we know that they do.
I let you put a pin in that.
Yeah, sure. You want to talk about the evidence for relativity?
Oh my gosh. He's like, oh, I gotta get out of this topic. Astrokate says, lol, I bet Soli doesn't know what a Q factor is. Obviously, Soli doesn't even know. He doesn't know any of the things that were in the papers and the formulas. He doesn't know what the water vapor number is. There's 2 constants in that equation he tried to use on Thursday. None of this is stuff that he understands. When I bring something up, when I prepare, especially if I'm going to prepare for something like a modern day debate, I put a lot of time into preparing that. I want to know everything well on that topic, and I'm not bringing in things that I don't understand. So, Unfornicated Dan, who's in the chat here, he helped me a lot on the particular the LoRaWAN that we thought Soli was going to bring up, and in fact he did bring up, and that was the first 48 minutes of this particular conversation here with Blitz. and Dan knows the topic a lot deeper than I do. But the stuff that I chose to cover, and he went over more things. Like, I talked to him for quite a while. We went over, I'm like, I don't have the depth on that topic, so I'm not going to include that. And so I put in the things that I could cover. I don't want to speak outside of what I have knowledge of. So I didn't talk about some of those things. Soli couldn't talk about anything if he did that, though. So tough for him. Unfornicated. Anyway, back to the. I don't, in this context, I don't know what the Q factor is either, though, Astrocade. But it probably doesn't matter because he doesn't know for sure. Unfornicated says we use 2/3 R for cell tower worst case. Imagine River Valley in summer at dawn. I have used 1 in modeling, but I've been doing it longer than 2 weeks. Yeah, because if you need to be certain that the signal is going to get there, like you're going to install a permanent site-to-site transmitter receiver pair, you want to know that under all conditions, or at least the broad conditions that are the large portion of the time, you need to know that when the light is bending down, or when the photons are bending down, or when the photons are bending up, right, that you can get that signal all the way across. So you need to model the whole gamut. And so, yep, there are times when you're going to use 2 over 3R potentially, and 4 over 3R. So yeah, and that's your problem. Obviously, you only need 2 weeks, and then you can cook. You can go toe to toe. DP Debunk says, I keep hearing 4chan and get concerned. Icy Spin says, this is like Butterbean versus Johnny Knoxville fight. Oh my gosh, Butterbean. That big boy. Jack Fetter says, looks like I may not need the 2 weeks after all. I decided to start with ChatGPT. What shape is the Earth? Spoiler alert, not flat. Wah, wah. Real Harnold says he meant derivative of P. What? Okay. Unfornicated says he didn't go toe to toe. He got bent over and spanked by Dr. Bliss repeatedly. But we don't kink shame here. 78 Mitsu says, is the faceplate PPE still on sale this week? Where's mine? Oh yeah, I got the Witspit one right here. Just be careful. Practice safe Witspitting. How different does it sound, this versus this? When I have it on, I can really hear the difference in my own ears. I imagine that it's quite a bit different to you guys. But I don't know. I've never tested it. Let's see. We got the Rebel Raider sent a sticker. Thank you very much for that. Lindsay Bow is a new member at Einstein. Thank you very much. Appreciate that. All you members, man, you guys are so awesome. I mentioned, this is what's cool. I mentioned that the computer I have right now is getting a little bit slow. And some people are like, oh, we'll help you fund it, stuff like that. I don't like to do fundraisers. I want to just put money aside, and when I have enough money aside, go do it. And I don't like to ask. Well, somebody sent me an email, and I'll send you an email back offering to borrow a computer for a while, and very generous. And I'm like, yeah, I think that'll work. So there's your answer. I'll send you an email when I'm done with this. I think that's a good idea, and I think we can maybe make that work out. You guys are great, and so what I'm probably going to do is borrow that until I have enough saved up to purchase, and when Apple is able to manufacture the M5 Mac Mini, and I'll get one then. So, and in the meantime, I'll save up for it, but it will allow me to do a little more stuff, hopefully to dual stream on TikTok. That's really my hope in this. So that's what I'm looking for. Hopefully that'll work. Details to come, but that's what's so great. Members and super chats and just viewing the videos, means a lot. It means a lot. So thank you to everybody. Algorithm says, Soli is the steak that you seared 5 days ago in Blitz, stuck in the oven to bake. You can try to baste him, but he's way too overcooked to be saved. He's basically hockey puck now. Truther says, always test your hypotenuse. It's a 45-degree angle. That's right. According to Alan, one of the Ether cosplay boys, the hypotenuse is 45 degrees. That's not how it works. DP Debunk says, Blitz, stop. He's already dead. RG Silver says, wait for the Mac Studio with the M5. I'm going to wait for the M5. I am. Whether I get the M5 Studio or the M5 Mini, that is yet to be determined based on budget. I obviously would love to get the pimped out M5 Studio with everything, but you know, the reality is that I may or may not be able to get that much of a machine. I just this week hit full usage of my 61 terabyte array that I have sitting on the desk here. I have been completely uncareful in my usage of it. So right away I'm like, oh, okay, delete this, and now I'm back to like 2 terabytes open. But I'm like, oh, wow, 61 terabytes. That's a lot. It's not all on Dropbox. In fact, I had to get a subscription to sync.com. Dropbox is super useful. I can send links and everything is really good. I can selectively sync things and unsync things. I have them online or offline. Sync.com doesn't have that, but they do have one thing: unlimited storage. So that's why I use both. I have a hybrid setup. I have some software I've written that manages videos that I have, because I got a lot of flat earth videos and stuff. And so I've got a lot of them are in Dropbox, and Dropbox was getting full. And so I got Sync. And so it processes videos that are on my Dropbox, and then it migrates them over to Sync. Not super fast. It does it a little bit at a time. So I'm not just chugging up the internet here. And also not like, if I move something from Dropbox to Sync, well, it's deleted from Dropbox right away and not uploaded to sync.com right away. So there's a time where it's not on both. It's only on my hard drive. Though Dropbox does have versioning, so I can get it back. But I want to minimize that window. Anyway. Oh, this is good. This is good. I'm going to pin that for you, Jord. So there's still more to come in the conversation. 9 minutes left. And I think they do get into some pretty interesting things on relativity. And I can't believe that Soli wanted to talk relativity with Blitz, because holy crap, he's going to be out of his depth, out of his league. Anyway, and the Jord said, says 1 week from today, come watch me beat up FTFE on Debate Hub. I wish you had tagged me on it, because then I could put it up on screen. I should probably just put FTFE in my thing there to capture. Anyway, he gave me his presentation. It's pretty good. You know, I love FTFE. You know that. He's me, basically. He's the British version of me. At least all the flirts get so confused about it. But I think Jord's gonna win this particular debate. So just be ready, Craig. I'm just telling you. It's not gonna be easy for you, Craig. You're gonna get spanked like Soli's getting spanked. All right, let's get back to Soli here.
What does
the evidence,
what
all of the
disproves
evidence, all of the evidence for special relativity is evidence against the ether, right? The two are incompatible.
I need specifics.
Okay. So are you familiar
I
with...
agree that they're incompatible. I actually do agree.
By the way, for some reason it says you're teacupped, but I can hear you.
It must be a TikTok thing.
Can't call it, bro. TikTok's weird.
Okay, one sec. Let me pull something up. Here's
I promise you, I'm looking at your face. You're looking to.
Okay.
You're right.
Just checking.
Well, you were.
So here is a nice summary. It's a nice web page that has some... Let me just zoom this in a little bit. It'll make it easier to read. And it'll take up less space. So this is maintained by Tom Roberts. The name doesn't have to mean anything to you, but it's just a name. Sorry, I'm just getting the sizing right. And so here's a page that has all...
We can see that strong chin that Blitz has rocking there.
All of the experimental evidence in support of relativity. And we can just go find one that's, and by the way, these are pre-1905 experiments. We can go scroll to particular ones. If you want ones of time dilation, for example, there's a really famous one. Or wait a minute, this is the one I was thinking of, Ives and Stillwell. I was thinking of the one that involves muons, which I think I have somewhere.
Yeah.
I made a video about it. Oh, no, I'm sorry, it was this one. It was the measurements of particle lifetimes. So here, they actually made a movie about this, which is really neat, and it exists on YouTube, where they...
It is a good like documentary movie kind of thing. I recommend it. Maybe he'll mention it, or maybe if somebody can find it and link it, I'll mention, and tag me so that I can put it on screen.
They actually like go over what the experiment is and what they showed and how they collected data and things like that. I can pull up the video if you want. It's available. You can watch it on YouTube. Just so people can take a screenshot. I'm going to pull it up.
Videos too. You ever see The Principle?
Lifetime experiment. I have no idea what that is.
I'm sure you do, actually. Somebody's probably brought that to your attention.
What's it called?
It actually gets into it gets into relativity pretty good. It gets into like Hubble tension.
Yeah, things that he doesn't understand. Anyway, this is it here. A great little documentary there. 35 minutes worth your time.
And dark matter and dark energy.
What's
and
it called?
Cosmological fine-tuning problems like the...
What's it
It's called The Principle, 2014.
I've never heard of it.
For reference, The Principle is done by a geocentric glober. So it does not support flat Earth at all. If you accept anything in that, if you accept what The Principle is presenting, you also accept that the Earth is a globe. It's absolutely mandatory for everything in The Principle.
You know what the Copernican principle is?
Yeah.
Yeah, it talks about that.
So it's okay. So this is a documentary from 1962. It's 35 minutes long. It's fairly short, and it was basically made as part of an experiment. So you have some scientists that were running this experiment, and I think that they had like an undergrad student, or maybe it was a grad student, that said, "Hey, it'd be really cool if we also made a movie out of this, so that." We can kind of teach people about this strange thing that we're measuring. And so they did. And it's actually like it's just really well done. It's from the 60s, of course, so things are a little bit slow. But I would definitely recommend people check this out. It's a really well done documentary, and it explains how they're actually providing evidence for special relativity. That's what's in question here. In particular, there's a certain kind of muon, or a certain kind of particle. They thought that they were mesons at the time.
Everybody watch The Principle 2014 by...
Okay.
I would recommend the 2014 Principle.
Yeah. Why are you talking about that? You wanted to talk about a different topic, and now we're talking about that different topic, and you got to interject this other advertisement for a globe presentation. Good job, Soli. It still destroys flat Earth, you dummy.
Principle 2014 as well. You see how this is like we could go tit for tat on YouTube videos?
Well, look,
You're not going tit for tat. The Principle is not a documentary.
The reason I gave you this is because people, often flat earthers don't like looking at scientific papers. They prefer YouTube videos for whatever reason. So this is a YouTube video where they explain the entire scientific process.
I gave you scientific papers. We talked about scientific papers.
No, we didn't. Are you talking about this? This isn't a scientific paper.
He thinks that is a scientific paper.
This is a PowerPoint by at some engineering
I gave you sources
firm.
from NASA, bro.
You didn't give me any sources from NASA. I'd love to look at them.
I gave you a NASA source.
You gave me a quote that you said was from NASA,
Originally,
but you
when
didn't
the
give me any.
conversation first started,
You didn't
I
give
gave
me
you
any sources when the conversation first started. But anyway, so
I can bring it back.
Oh,
if you want
bless.
more evidence for relativity, this is the place to go.
All right. Here is X Illusion X has the right here. This is the link. This is the one. If you want to click on it now and then watch it later, there it is. And that's what Blitz just showed the link to. So I don't know if we're going to get much into it. I don't think he's going to play it much. That's not really the point.
There are literally hundreds of papers and dozens of types of experiments that demonstrate the validity of special relativity. It just goes on for so long.
Are we gonna get a chance to talk about the dark matter and dark energy problems that come with relativity?
Those aren't problems for special relativity.
That's how dumb he is. He thinks it's a problem with special relativity.
They're not?
No.
Missing mass, missing
It's not,
energy
those
is
aren't
not
problems
a
for special relativity.
problem?
I have a feeling that you don't know what special relativity is.
How do you remedy them then? How do you remedy
Special
that?
It's a different topic. He can't even stay on one topic.
relativity doesn't care about mass at all. Special relativity doesn't include gravity. I guess you don't know this.
General relativity superseded it, so you're not even on
General relativity superseded special relativity? Oh dear, it did not.
board with this.
General relativity could be wrong.
and
Special
we're
relativity is
talking
not in
about-
question. And special relativity is the thing that dismantles the ether.
Still, you have. Okay, but you still have missing mass, right?
That's a cool pivot away from special relativity. It's completely unrelated.
Well, you didn't disprove the ether, so you pivoted away as well. Like
I gave you an entire web page. I
right?
gave you an entire web page that, and you can peruse
You
it for
didn't
yourself.
read a single source.
Do you want me to go? Do you want me to go pull one up for you? I can pull one up for
Yeah,
you if you want.
yeah, you're gonna have to, I guess.
Let's read what they say on Michelson Morley. Let's read what they say.
Oh, wait, do you want me to provide you the evidence that I think is evidence for special relativity? Or we could go look at Michelson Morley, but that's just from
We're
before.
talking about disproving the ether, so I would imagine going to a source
Well,
that has to do with ether would be a good place to
be
start.
clear, what we're talking about is we're talking about providing evidence for special relativity.
Are you scared to show Michelson Morley in front
Oh
of
my
1,000 people?
gosh.
What's going on?
Let's read this together.
Yeah, let's do that.
Hold on, I'm going to zoom in a little bit just so then it's bigger so then we can all see what I'm reading.
Oh. Soli must not know Blitz's background.
Is this big enough? Can you guys see it?
Relative to the luminiferous ether, yes.
It was intended to measure Earth's velocity relative to the luminiferous ether, which was at the time presumed to carry electromagnetic phenomena. The
Did they
failure of it
assume-
and other experiments to
assume the
actually
ether
observe
was
Earth's
dynamic?
motion. The failure of it and other early
they
experiments.
assume-
Wait, you told me to go read about what it says about the Michelson-Morley experiment. I'm doing that. So please don't interrupt. The
Did
failure
they
of it.
assume a dynamic or a
The failure of
stationary
it and
ether?
other early experiments to actually observe Earth's
they
motion
assume a
through the
dynamic
ether.
or a
I'm going
stationary
to
ether,
read
Blitz?
this. I'm going to read this like you asked me to, okay? This is your request. I wanted to look at muon light times,
okay,
but you
don't want
wanted
to
to
answer
cherry pick.
questions about it, right?
I'm in the middle
You
of
don't wanna
reading it.
answer
We can talk
questions
about it
about it.
afterwards.
What an absolute child. Soli, you asked him to do this. He's doing this. You need to stop talking over him. You're obviously scared because this isn't going to support you. And you, right? This is the typical flirt. You've got to control and only focus on the little tiny cherry picked section that you want that supports your position. Right? That's all you want. You don't want to have a broad understanding. You don't want to have the full truth. You don't want to have all the information available. You only want to have the one thing that can fool and deceive the gullible people that are your followers. That's why he's doing this.
I'm in the middle of
Do you
reading
want?
it.
Did they assume?
Okay,
this
so-
is a very beginning. This is very beginner
why
level
don't you just
stuff.
let me read the
Did
thing
they
that you asked
assume
me to read?
stationary? Why
What?
don't you answer my question?
So-
did they assume a stationary ether?
So in the case of Michelson-Morley, they were investigating whether there was an ether
did they
wind.
assume a stationary?
They were investigating whether there was an ether wind.
Did they assume a stationary?
They didn't
They
assume
assumed a
anything. They
stationary
were
ether.
looking for an ether wind, and they were trying to see if
And they did get a friendship.
they were trying to see if there was any sort of detectable ether wind, and the answer is apparently no. The failure of it and
They got
other
a
early
friendship.
experiments. The failure of it and other early experiments to actually observe Earth's motion
They
through
got
the
a
ether.
friendship.
Okay, so
Oh
I'm
my
going
gosh.
to take up my headphones and I'm going to turn you down so that I can finish reading this. Okay. So the failure of it and other early
I'll
experiments
see
to
my
actually
way out,
observe
bro.
Earth's motion
I'll
through
see
the
my
ether
way
became
out. This is
significant
taking
in
up too much.
Bye. Nobody will miss you.
Relativity, as it was appreciated from early on that Einstein's approach via symmetry was more elegant and parsimonious of assumptions than were other approaches, those of Maxwell, Hertz, Stokes, Fresnel, Lorentz, Ritz, and Abraham. The following table comes from R. Shankland et al., and here's the citation, which includes references to each experiment, resolution, and limit on the ether from the original sources. The expected fringe shift is what would be expected for a rigid ether at rest with respect to Sun and Earth's orbital speed, 30 kilometers per second. So the Michelson-Morley, so they expected a 0.04 fringe shift, and they measured a 0.02. Apparently, they didn't provide an experimental resolution. That was Michelson. The Michelson-Morley expected a 0.04 fringe shift and measured less than 0.01. with an upper limit on the speed of the ether of 8 kilometers per second. And then we have a whole bunch of other experiments, Morley, Miller, we have Tomaszek, we have Miller again. This was a reanalysis done here. We have Kennedy, Illingworth, Picard and Stahl, Michelson et al., and Juice. So apparently before 1950, it was common to not perform a detailed error analysis and to not report error bars or resolutions. Now that I'm done reading that, do you want to say something? Oh, did I turn myself down? I may have turned myself down. Rest in peace. Oh, he ran.
Oh my gosh. He just ran away. He scampered off as soon as the topic of ether was brought up. Well done, Blitz. Well done. Poor guy. I mean, he should probably change his name, get plastic surgery, move to a different country, never go on the internet again. That was embarrassing, Soli. Very embarrassing. So remember, he's got a script. He was given a script by Witsbit and others. And it originated really, I think Gleam is one of the originators of bringing those things in to the conversation. And Gleam doesn't even think that the earth is flat. Anyway, just for reference to people, Michelson Morley was not looking for the ether, as flat earthers like to claim. Michelson Morley knew that they were not, let me back up. I said that wrong. They were not looking to measure whether or not the earth was moving. That was not the intention of the test. They knew that it was moving. In fact, the very first sentence of the paper mentions the aberration of starlight from 150 years prior, where it was determined not only that the earth was orbiting the sun, but the speed at which it was orbiting the sun. So that was a known thing that was not in question. It was whether or not there was an ether. And so they assumed, they were testing as part of their hypothesis that the ether was at some sort of an absolute stationary within the universe. Now, this was before it was well understood that the solar system is moving through around the galaxy, and that the galaxy is moving through, in relation to other things within the universe. So all they knew at the time was that the Earth and Sun and the solar system and things like that. So they had said, well, they had hypothesized that the ether was stationary, and that the Earth was moving through it, and then they tested to see whether or not this was the case, and they did not find any value. Right? They're like, he's like, they found a fringe shift. So get back to that in a second. So the result was essentially zero. The margin of error of the analysis was not insignificant. There was some margin of error, and so that's the fringe shift they're talking about. But it wasn't much, and it wasn't always in the right direction either. There was some fringe shifts that were the wrong direction, right? And any fringe shifts that they might have found, and if you're going to try to confirm, say, well, that it did measure the movement of the Earth through the ether. All that you do then is you confirm that the Earth is a globe, and the globe is orbiting the sun, and that the ether exists. You don't win as a flat earther in this instance anyway. But they did not, in fact, measure that in future measurements. And the one that Blitz just showed only went up to 1930. They've done significantly more precise measurements since then, and found the error bars are significantly smaller. It's like 1 billion times smaller than the original. On my website, MCToon.net, I have Michelson Morley Redux, REDUX. I don't know. You can, I think if you can just search my website for MMX, you might find a page that is a listing, like a short listing of different, hold on. MMX. No. Not to do. Ether. That's not it. Aha, there it is. Okay. Here's a short list of different tests, similar tests to Michelson Morley with more and more precision. So if you want to look in there. So the fact that in the very first test, they did find some fringe shift. They certainly did. But in future ones, they tightened up significantly the margin of error, and the fringe shift that they found was just regular margin of error. So the conclusion that you can draw from Michelson-Morley is because there's no question about whether or not the Earth is moving around the sun. That was already confirmed 150 years prior. That ether doesn't exist, or this is a tough one. That the ether is at rest with respect to the surface of the Earth. And if that's the case, then the Earth must drag the ether with it around the sun and as it rotates. A big, right? That big assumption, and doesn't work with the idea of what they thought the luminiferous ether was. They thought it was a medium. And for the physical Earth to move that medium with it, well, that's a pretty big thing. They've found in other experiments that wasn't the case anyway since then. So, okay, we got Conspiracy Music Studio says, I bet Solid learned nothing from this, or the MDD. No, remember, he is not seeking truth. Soli is not seeking truth. If he was, then he would have looked at that, the neutrino experiment and said, hey, wow, that says a lot. Better investigate that. Nah, he didn't care. He didn't care. And since then, the one day since then, has he looked at it? No. Will he look at it in the next 5 days? Will he look at it in the next month? Will he look at it in the next year? No, he won't. Only will he look at it so that he might be able to attempt to refute it instead of look for truth. That's all he cares about. He doesn't care about truth. He cares about getting points with his bros on TikTok by being able to refute real science with garbage. So no, he won't. He didn't learn anything. Truth Nerd says, yes, the principle. Robert Sungenis' Globe's geocentrism derp film, where they literally had to trick the narrator and other participants into thinking it was an actual science movie. That's right. Captain Janeway from Star Trek is the voice. They tricked her. I think they got her to sign the contract. She was committed to the contract before she knew what it was, and then had to keep the contract. So Truth Nerd says, but MCToon, if there is optical Ethernet, there must be luminiferous ether. Checkmate, Globetart. There is optical Ethernet. You can send Ethernet through optical fibers. Indeed you can. Let's see. Mystery Man says, Q is a function of resistance in reference to gain in an antenna. Okay, that's what that was meaning. I think I'm a little bit rusty on that. In my electrical engineering coursework, of course, like a huge portion of it is math, more math. And then you take electromagnetism, you take a handful of other classes, and one class on antennas. So I took that one class and did not use it because I didn't go into that field. I've been writing software for my professional career. And until the 5G stuff came up, when I'm like, oh yeah, this was a class I took several years ago and I had to brush up on it a little bit. So the Q definitely don't recall. So thank you for reminding me. Let's see, Elder Bear. The negatives of the blue marble are displayed to the public. It's up to you to go see them if you want proof firsthand. Well, they're not negatives. They're actually photographic slides, so they're positives. If you scan them, you don't need to invert the colors. They're already the correct colors. So if your grandparents ever had the, like mine, they had that seat in the living room, and you open it up and there's a whole bunch of square boxes about this big. And in there is a donut kind of thing that's got a whole bunch of slides in it. Those are photographic slides. And so the way it actually works, and this is cool. I didn't know this until later, and I got to understanding photography a little better. Of course, this is all not what people do much anymore. But a photographic slide is a different type of film. It takes a positive instead of a negative. So when you develop the film, you get the slide as the result. You don't get a photograph. You can if you want, but you don't get photographs. So if you ever went to the store and you had your film developed, you got the photographs, a handful of photographs, a stack of 24 photographs, something like that, plus the negatives, right? The negatives are the actual film that was in your camera. They give that back to you. If you get photographic slides developed, all you get back is the film. That's it, nothing else. Unless you could also choose to have the photographs developed, and that's a different process because it's not a negative, it's a positive. Anyway, so that's what they actually have in Houston in cold storage. And they're not cut up, they're still on rolls. So the roll that was in the camera brought to the moon, photographs of were taken, and then that roll was brought back to Earth, wet developed in a darkroom, and then that roll was what they used to create the photographs of it, and also that roll was what they used to scan on a digital scanner and then upload in multiple different archives, including the most recent high quality one that I know of, which is hosted by the Arizona State University March to the Moon. So if you just Google March to the Moon ASU, you can find them. Those are the highest resolution slides available. They are available as TIFF files that are uncompressed. And the resolution, this is an important thing, the resolution of the scanner is supposed to be a higher resolution than the grain that the film is recorded on. So it's supposed to be the highest possible resolution. You could go back and rescan it with a better scanner, but you won't actually get a more detailed photograph because the grains of the little bits of color sensitive stuff on the actual film, that's what's there. It's a higher resolution than that already. So, but yes, Elder Bear, if you actually were the truth seeker, you're not, right? But if you were, you could say, you know what, I want to go examine them. And you could go and you could get maybe a photographic forensic expert, maybe go to your community and fundraise a little bit to get some sort of, a trip there for yourself. I think you're in England, and you could go there, bring a photographic expert, and do a proposal. I proposed to them to NASA and say, hey, I'd like access to these. I have this experiment that I want to do. This is for academia. Here's what we're going to do. We're going to look at them. We're going to examine them. We're going to, whatever it is that you think that you need to do to determine whether or not they're real. Now, if that's not what you need, you could just go look at the TIFFs, the high resolution uncompressed TIFF files, and look at them. All right. Or maybe you're like, I don't believe those TIFF files are the same as the actual raw photos. So you could say that's what we're going to test. We're going to go there and we're going to identify photograph 27727 from Apollo 17 flow state. Yay. Thanks. And that could be your thing. You could say, well, we're going to take a handful of iconic photographs that really do, if they're real photographs, really do establish that the Earth is a globe or not, right? And look at them on the original slides and compare to the I got another one, the bag that's sent to flow state, and then the Rebel Raider sent a laughing disco. Oh, it's off screen. Hold on. There it is there. The laughing disco. Thank you. Anyway, you could do that if you cared about the truth. But if you don't care about the truth, then you won't care, right? You'll just hand wave it, right? Anyway, RG Silver's wait for the Mac Studio with the M5. Yep. All right. There's my link. It caught my own link. Ah, Dick Wayne finally crossed the line. Wow. I believe it. Let's see if I can find where he was. What did he say? The most recent thing he said. Is dreaming of stranger really? Is it? Wow, Dick Wayne, you're gross, Dick Wayne. What a sad person you are. Oh my gosh, Dick Wayne. I mean it's gross. I wouldn't say it crossed the line into that, right? That area. He said to Lindsay Bowe, "So you are dumber than a grade schooler?" God, it makes sense now. No. Oh, Dick Wayne, you're the dumb one. You're the dumb one. You're actually calling people that understand this topic mentally retarded. Wow. That's classy. Anyway, well, thank you for that. Yeah. Okay. Well, let's see. Oh, hold on. Where'd it go? There it is. Okay. I think I already read that. Yeah. Optical Ethernet. We got Unfornicated says, I shot slide film. Damn it. I'm not a grandparent. I never did a lot with film. I've seen the inside of a dark room, but I never developed myself. I knew people that did. They thought it was awesome. I'm like, didn't need it. Anyway. Okay. So these gem things, they are showing up. So like this one here, the eye bag showed up and the Rebel Raider showed up. So I need to fix this, enhance this somehow to capture these better so that I can review them and put them up somehow. I don't know. Well, I'll see what I can do to capture them better so that I can acknowledge it. So, all right. He then ran because he knew we'd time him out forever. Yeah, that's true. So, I mean, it's kind of fun to play Whack-A-Troll with Dick Wayne, and he really is just a sad, pathetic little boy, right? Like everything is nuh-uh. That's all he has. His hardest evidence is nuh-uh. I mean, Elderbear, he's actually a little funny. He's like, all horizontals will be parallel to the horizontal diameter of a sphere. That's some word salad. All horizontals. Okay, so here's a sphere. And all horizontal. So here is a horizontal, right? Will be parallel to the horizontal diameter of a sphere. Now the diameter is just a number, right? It's the radius is 6371 and the diameter is going to be 12,600 or 12,700 something, right? That's just a number. So you can't have parallel to a number. But he's saying the horizontal diameter. What's the horizontal diameter? Okay, the horizontal diameter would be this distance here. Okay. All horizontals will be parallel to the horizontal diameter of a sphere. Well, the horizontal diameter of a sphere right here, from this side over here to this side over here, right? The horizontal diameter, that's going to be a line, right? Because the diameter is a line. It can't be a circle. It can't be a plane. It's a line. It's going to go start here and end here. Okay. On the radius here. So that line right there, there's going to be two lines on the surface here that are horizontals that will be parallel to it. The one on the North Pole, the one on the South Pole. They will be parallel to this line here that I can't show you. It's going to be here inside the actual sphere. That's going to be the horizontal diameter. Okay, if I'm understanding what you're saying there right. Now, he's a flat earther. So it's a little bit difficult to get him to speak intelligently about geometry because they suck at geometry. So Anyway, sometimes it's just kind of like a fun thing to try to decipher what they mean by some nonsense that they're chucking out there. Anyway, it's 1:11 a.m. 3 hours and 11 minutes. Anyway, people, I love you guys. You're so nice. Oh, I didn't. Okay, so if somebody goes there, grab a screenshot of it. I put it into their folder, their Flurf folder, or you could put it on Flurf Wiki. That's another thing, right? So I have a folder for each Flurf, and I just dropped stuff in there. And my vision is that the things that I put into the Flurf Wiki folder the Flurf folder on my computer should wind up eventually on the Flurf Wiki page, right? And if you all have a folder for each Flurf that you encounter, do the same thing. Pop it up on the Flurf Wiki for humanity. So, vertical is not parallel to horizontal, says Elderbear. A vertical is not parallel to horizontal. Well, that would be incorrect on a sphere. Because you're talking about the general, in all cases, right? You didn't specify, so I'm going to take that you mean in all cases. So a vertical can be parallel. So if you take vertical to the equator, that's this right here, right? Vertical to the equator. So what is parallel to this? Well, again, it's going to be the horizontal at the North Pole and the horizontal at the South Pole. Those two are parallel to, on a sphere, to vertical on the equator. This is just geometry, right? Now, you of course, being a flat earther, Elderbear, you do not claim this to be the case in reality. It is the case in reality, but fine. We're just talking pure geometry. Yes, in pure geometry, this is vertical, this is horizontal, and they are parallel to each other. Because vertical and horizontal is defined on the surface of a sphere relative to just one point on the surface of the sphere. But Elderbear, being a Flurf, is very derpy. And that's why we like him, because he's so derpy. So, anyway, Thursday. I plan to do a live stream Thursday at 1 a.m. Central Time, which is really Friday. That's the big time. That's when we will have Creaky, because that's all that matters, and some other people. I might be there too. Those other people that might be there is me, Flat Earth Reconnaissance, and I don't know, maybe Mikey Smith. But who cares about all that? Creaky is the only one that matters. He'll be here. It's going to be a good time. I hope that you all can make it. I know it's an inconvenient time, though. If you're here right now, it will have started 15 minutes prior on that same day. So, maybe it'll be fine for you. I don't know. Anyway, I think we really did find out that how incredibly humble Soli is, because he thought he went toe-to-toe with Blitz. He did not. Blitz, thank you very much. You did amazing, as always. Love watching your stuff. And if you haven't yet, you need to go subscribe to him. The link is in the description. Subscribe and watch his videos, and give it a thumbs up and hype it, and send him gems and all that good stuff. People, we'll see you on Thursday.
Use wits, it gets it, step into the mic, bro. Talking flat earth, get ready for the hype, bro. Aced algebra in school, honors too, bro. Gravity's a lie, yeah, I'm in the zone, bro. Electrostatics, that's the real deal, bro. They say the earth's a globe, but that ain't right, bro. I'm the best flat earth debater, bro. Humbly, opposition ain't on my level, so, but let's not get too technical, bro. This is so funny, I'm getting crushed, bro. I'm schooling you, bro. You are literally losing the debate, bro. You are so out of your league, bro. crush, bro. I'm schooling you, bro. You are literally losing the debate, bro. You are so out of your league, bro. Our model, though not defined in full, bro, is superior. Your model's falsified, bro. Van de Graaff generator, electrostatics a maze, bro. May objects change weight, just a phase, bro. 100 volts per meter electric field, you know, bro. Flipped it with 400,000 volts, whoa. Small bits floated, defying gravity like totally, bro. Next I'll rub a cat to a brick the show, bro. This is so funny, you're getting crushed, bro. I'm schooling you, bro. You are literally losing the debate, bro. You are so out of your league, bro. This is so funny, you're getting crushed, bro. I'm schooling you, bro. You are literally losing the debate, bro. You are so out of your league, bro. MCToon and Globers, you can't deny, bro. Wits it gets, it's here to testify, bro. Most times I don't remember you exist, yo. I'm the flat earth king, you better believe it's so. Moon phases are like a magnetic cycle, bro. Center of a ferrocell, image magnets glow, bro. Charge up and down, etherically displaced, yo. Kinematic equivalence explains it all somehow, bro. It might sound tough, but let's skip details, yo. You might believe I have an amplitude for math, ho. It's all just a lot of salad in my words, yo. This is so funny, you're getting crushed, bro. I'm schooling you, bro. You are literally losing the debate, bro. You are so out of your league, bro. This is so funny, you're getting crushed, bro. I'm schooling you, bro. You are literally losing the debate, bro. You are so out of your league, bro. And what happened is they brought in Einstein to totally save the physics redefined, to flip physics all on its head, bro. To keep Earth moving around the sun, you know. And in the magnetic tourist field, I say the path of planets fits perfectly. This is so funny, you're getting crushed, bro. I'm schooling you, bro. You are literally losing the debate, bro. You are so out of your league, bro. This is so funny, you're getting crushed, bro. I'm schooling you, bro. You are literally losing the debate, bro. You are so out of your league, bro. If this debate was a rap battle, I would have totally won, bro.